Hey everybody, it's me, the Shy Hat, and we are HackerFrogs. All right, so everybody, let's talk about what we're going to be doing today. We're having a little conversation with Valenhex and Cybernerd Dante in chat right now, and it looks like Hack the Box likes to pay people to create CTF labs for them. All right, and it looks like they pay different amounts of money depending on what certifications the creator has. That's very interesting. I'm wondering if it's worth it to go full time as a content creator for Hack the Box. If it could be like something that you do as a regular job. But yeah, okay. So Valenhex also has a little as a link for us, and let's see if we can share it with everybody else in chat. But if you are a person who likes writing CTF labs and you're interested in making some money, sounds like something you could look into. All right, so what are we going to be doing today? So we're going to be doing 3 separate activities like we always do on our live stream, and let's talk a little bit about that. So the first thing we're going to be doing today is we're going to be talking more about where did my I was doing something with we're going to be doing some more cryptography today for our first activity. And yeah, we're going to be taking a look at classical ciphers, part 2. So we're going to be taking a look at more classical ciphers that you're going to be running into when you do CTF challenges in the cryptography category. And that's going to be the first part of today's stream. So look forward to that. And for the second part of today's stream, we're going to be going off the beaten path, and we're going to be talking about something that we really haven't done too much of on this stream, anyways. And that's going to be some x86 assembly basics. So we're going to be learning about how to write code in x86 assembly for Linux. And we're going to be writing the Hello World program. We're going to be talking about how assembly code works and how to write assembly code and how to read assembly code. And that's going to be the second portion of today's stream. In the third portion of today's stream, we're going to be going back to the we're going to be going back to the Docker labs, and the Docker labs are a collection of different vulnerable CTF Docker containers, and these all run Linux. So we're going to be doing some Linux hacking. There's a very high likelihood that we're going to be doing some web app hacking as well, because most of these containers have some sort of web app running on them that we need to compromise. And that's going to be the third part of today's stream. So that's going to be in a couple of hours, and that's the third part. In the second part, which is going to happen in about an hour or so, we're going to be taking a look at x86 assembly basics, and the first part is going to be talking about cryptography. So let's get started with our cryptography lesson. All right, let's go. So this is HackerFrogs After School. We're talking cryptography, and we're talking about classical ciphers. This is part 2, and if you want to participate, you're going to need an account over at the PicoCTF website, but don't worry, we've got you covered over here. All you need to do is go to this link and sign up for an account. All right, so let us begin. So hey there, HackerFrogs. This workshop is the third session for cryptography basics. And in the last session, we learned about the following cryptography concepts. So we learned about cryptography terms. These are terms that we need to know if we want to talk about cryptography. Things like ciphers and plaintext and ciphertext encryption and decryption. These are all terms we need to know to study cryptography. We talked about the ROT13 cipher, which is a simple substitution cipher where the encryption method is to shift each plaintext letter 13 positions in the alphabet to form the ciphertext. So ROT13 is a very easy to understand cipher, and it's actually part of a larger cipher that is called the Caesar cipher. And the Caesar cipher is a substitution cipher where the method of encryption is to shift each letter of the plaintext by a specific number of letters in the alphabet, called a shift or a key. So the Caesar cipher, there are 26 different versions of the Caesar cipher. And when I say 26 versions, all I mean is that the letters are shifted by a number of letters equal to the key number. So a shift of 1 is shifting each letter forward in the alphabet by 1. It's not too difficult to understand. Okay, so let's get on to this session's topics. We're going to be covering we're probably going to cover at least 2 different ciphers today. If we have time, we're going to move on. We're going to talk about the third cipher here. But the first 2 we're going to cover are the Wegener cipher, then the rail fence cipher, and then the transposition cipher. So that's a bit of a misnomer since the rail fence cipher is a transposition cipher, but we'll talk more about that a little later. So let's talk about this Wegener cipher. The Wegener cipher is another type of symmetrical substitution cipher. So the Caesar cipher is another symmetrical substitution cipher. The Wegener cipher is a more complicated version. It is more complicated than the Caesar cipher, but it's at its heart, it's kind of similar to the Caesar cipher. So while the typical Caesar cipher uses a rotation number, which substitutes plain text letters for ciphertext letters, the Wegener cipher uses a key, which is mapped to the plain text characters before encryption can take place. So let's talk a little bit more about that. In cryptographic terms, a key is a string of numbers or letters which is used in a cipher's encryption and decryption process. So basically, for most of these ciphers, you would need a key and an encryption method, the cipher that is being used, before you can decrypt any message that was used using that cipher. So in the case of the Wegener cipher, the key is an alphabetic string of varying length where each plaintext letter is mapped to a letter in the key. So if that sounds a little bit confusing, we're going to talk a little bit more about that. So the first letter of the plaintext is mapped to the first letter of the key, the second letter of the plaintext is mapped to the second letter of the key, and so on and so on. So for example, given the plaintext crocodile and the key animal, the 2 would be mapped in the following way. So C and A are mapped together, R and N are mapped together, and so on and so on. So you might notice that the word crocodile is a bit longer than the word animal here. In this case, after all of the letters in the key are used up, then the key is going to loop over to the beginning of the key again. So animal, and then it goes back to A, and then I, and then I, and then N, and then I. So as indicated by the example above, if the number of letters in the key is shorter than the number of letters in the plaintext, the letters in the key will repeat from the beginning letter of the key until all of the letters in the plaintext are accounted for. So after the letters in the plaintext and the key are mapped to each other, each plaintext key and letter and key pair needs to be looked up on the Wegener table, which is a 26 by 26 table that looks like the following. So the Wegener table looks like this. So if you've got 1 letter of the plaintext and then 1 letter of the key, you can look up what the resulting character of the combination should be. So if you've got a plaintext of L and a key of O, then you would go down to here, and you see that the resulting letter here is the letter Z. Okay. So for each plaintext key pair, find the plaintext letter on the top row of the table and the key letter on the leftmost column of the table, and the key that is intersected by both the plaintext letter and the key is substituted in place of the plaintext letter as the ciphertext letter. So in the following screenshot, you will see the resulting ciphertext letters for the plaintext key combinations of CA, RN, and OI. So let's take a look. So if the plaintext is C and the key is A, then the result is the letter C. If the plaintext is O and the key is the letter I, then the resulting letter is the letter W. And if the plaintext is R and the key is N, then the resulting letter is the letter E. So as you can see, the resulting ciphertexts are this, this, and this, respectively. If we complete the example and encrypt the plaintext crocodile and the key animal using the Vigenère cipher, the resulting ciphertext is this right over here. So manual decryption of ciphertext encrypted using the Vigenère cipher is possible if the key is available. First, we need to identify the key letter and the ciphertext letter combinations, and then for each key ciphertext letter pairs, find the key letter in the leftmost column and the ciphertext letter in the key cells row. So once found, the letter at the top of the ciphertext letters column is the plaintext letter. So if we've got the ciphertext this, and we know that the key was the word animal, then we can again use the Vigenère table for decryption. So we'll demonstrate the first 3 letters over here. And if we know that the ciphertext is C and the key is A, then we see that the resulting letter is C. If we know that the and so on and so on. It's basically looking up the letters in one column and another, finding the intersecting letter. Okay, so let's learn a little bit more about this cipher using the PicoCTF website. And what we're going to do is we're going to solve this challenge. Let me go ahead and get the link for everybody. Just a second. Okay, so here we go. All right, so what we want to do is we want to go over to our PicoCTF, the PicoCTF website, and we're going to log in. If you're not logged in, then you can't access the challenge. We want to make sure that you're logged in first, and then you want to paste in the challenge link. And we're going to see that this is the challenge for us right now. So this is the Vigenère challenge. It's a medium level challenge from the cryptography category from the PicoCTF 2022 event. The description here says, can you decrypt this message? Decrypt this message using the key Scilab. Okay, so if we know that the key is Scilab and we have the message over here, we can probably figure out what the original message was. But before we do this challenge, we should probably start up the PicoCTF web shell so that we can work inside of there. Okay, so the PicoCTF web shell is a very convenient tool that we can use when we're using the PicoCTF website. And after you're logged in, you want to click on the practice button over here, and then it'll take you to that web page. From there, you should be able to access the web shell. And the web shell is going to be this button over here on the right-hand side of the screen. So go ahead and click on that. And the web shell is going to start up, and it should give you a session. You're going to see your username over here, -PicoCTF, and that's how you know that the web shell is working. So what we really want to do is we want to put this web shell in its own browser tab, which we can do by clicking on this button right here. Beside the help button, there's this button labeled Pop Out Web Shell Terminal. So go ahead and click on that. And it should open up the web shell in a separate browser tab. But if it doesn't work, like it doesn't work over here, we can close it and then we can try again. So we're going to click on the web shell button again, and then click on Pop Out Web Shell Terminal. So it might take a few tries for this to work out because sometimes the PicoCTF web server is kind of slow and unresponsive. But anyways, let's try that one more time. So we can also try reloading the web shell terminal. And then after restarting the web shell terminal, click on Pop Out Web Shell Terminal. Okay, it looks like it worked this time. Great. So you'll know that you have connectivity to the web shell when you see this welcome message over here, and you see the prompt over here that that says your username PicoCTF. Okay. So now that we have this started, let's try solving the challenge over here. Let me get the link for the challenge again and paste it in. Okay, so it says, can you decrypt this message? Decrypt the message, and the message is a link, and it says that the key is Scilab in all uppercase letters. So what we need to do is we need to copy the message file. So highlight the link, right-click, and then select Copy Link. After we do that, we can go over to our web shell. And the web shell is going to disconnect every once in a while. It's going to disconnect when you haven't done anything in the web shell for a little bit, but you can reconnect pretty easily. Just hit the Enter key, and you should be able to reconnect to your web shell. If it's not working, you can always reload the page. Are you finished? Hold on. We can reload the page. Looks like the server's not super responsive today. Let me try starting up my web shell again. Okay, are we connected? Awesome, awesome. All right, so I already have some files in here, so I'm just going to get rid of them real quick. Okay, so after you've come into your web shell, what we can do is you can download the file that from the link we just copied. So we can do wget and then space, and then paste in the link over here. The file should be called cipher.txt. Hit enter after that to download the file. Remember, it's wget space and then the link. Okay, so after that, you're going to see that the cipher.txt file has been saved to your directory. So just read it using the cat command. So that's going to be cat space cipher.txt. Okay, so this looks like some sort of flag. So we can tell that this looks very similar to a PicoCTF flag because we've got 4 small letters followed by 3 capital letters, and then there are these curly braces over here. So this looks very much like the PicoCTF flag wrapper, and that's what we're looking for. So what we're going to do is we're going to translate this message. So there's an automated way we can use to do this, or we could also use the manual way. So let's demonstrate what the automated way would look like first. So we can copy the flag, or the ciphertext rather, and then go over to Google, and we can Google some sort of website like decode.fr, which is a very popular site for decoding all sorts of messages using different encryption methods. And from here, we look up the Vigenère cipher. It should be, actually, we know what we should do. We should just look up decode Vigenère, like that. Okay, so this is the link over here, Vigenère cipher. And if anybody's wondering what page we're looking at, this is the page right over here. I'm going to copy the ciphertext one more time. Okay, then let's go over to the website. And what we would do is we would paste in our ciphertext over here. And then what we would do is we would specify the key. or password. So it says under here, decryption method, knowing the key / password, we know that it is the word Scilab because in the challenge, it tells us, oh, okay, let me get the link for the challenge one more time. Whoops, that's not it. Okay, so yeah, the key is Scilab. So we're going to use that to decrypt the message. And after we've punched in the word Scilab here, we can click on the decrypt button. And we see that this result looks off. Hold on. Did I copy that correctly? Let me take a look. Okay. No, this looks like the right. Okay. It seems that it didn't didn't do the job properly. We could always try. I wonder if this automatic decryption button works. Well, that's a lot of stuff to go through. Let's try another link. So we can just Google beginner cipher, and let's try using this website instead, the Crypty website. Okay, so we've got beginner cipher. We're going to do decode, and we're going to grab the string one more time. So this is the string. And if anybody's wondering what the string is, let's just paste it into chat. There you go. In the ciphertext window, we're just going to paste this in, and we're going to replace the key over here. So the key is going to be the Scilab key. Scilab. Okay, so we have to make sure that the key mode over here is set to repeat, so that if the length of the ciphertext is longer than the length of the key, we can keep on repeating the letters in the key as often as we need to. And we see that the plain text that came out here is don't use beginner cipher, and this is a PicoCTF flag. We can go ahead and copy this, and then go over to the PicoCTF page and paste in the flag and submit the flag. And it says we've solved the challenge. Great. So what we can also do is we can do manual decryption of the ciphertext using the beginner lookup table. So we've got let's see what this looks like in our PicoCTF web shell. So I'm just going to copy this flag, and then we're going to create a little file called, actually we can modify the cipher.txt file. So we've got cipher.txt over here. I'm just going to move the ciphertext over to the center of the screen so it's easier to see, and that's a little easier to see as well. Okay, so we know that the key associated with the text is Scilab. So Scilab, and we know that if we have a short key, we can always keep on repeating it for as many characters we require. So another thing that we have to keep in mind here is that when we don't translate something, then the key is not used. So in this case, we can't translate this. We can't translate these squiggly brackets to anything. So we're just going to go forward over here. Same thing with this squiggly bracket, but it doesn't really matter in this case. Okay, so what we would do is we would translate letter by letter with the beginner lookup table. So let's go ahead and try doing that. Okay, So we got the letter R and the letter C, and I think I've got a copy of the Vigenère table somewhere. Let's look it up online. Vigenère table. Okay. Let's go ahead and take a look at this thing. Let's put it in a new tab. Okay, so we've got the table over here. And what are the two letters that we need to look at? The two letters we need to look at are the letter C, the letter R, and the letter C. Okay, so we look up the letter R and the letter C. And this comes out to the letter T. Why does it come out to the letter T? That's a bit suspicious. Maybe we should be looking at letter R and the letter C. No, it's the same thing. That's that's curious. I should probably look up why that is a little bit later. But let's move on to the next cipher we're going to be covering today. And the next cipher we're going to be covering today is called the rail fence cipher. So this is a very interesting cipher as well, and it's fairly common. You'll see it fairly commonly in CTF challenges. Okay, there's an ad break happening on Twitch right now. So while the ad break is happening on Twitch, we will not go forward because we don't want anybody to miss anything. Everybody on YouTube, I'm going to be playing an ad on YouTube as well, just so that the ads don't appear randomly. So get ready for the ad. In 3, 2, 1. Okay, but for everybody else, we can start watching some bird feeder clips. And how about this one that I recorded when it was snowing over here? So in the meantime, I'm going to take a little sip of water. Gotta hydrate myself just a second. Okay, so it's actually very important to, if you're going to feed the animals, it's more important to feed the animals when they can't get food. And when it's really snowy like this, it's difficult for animals to find food. That's when the animals appreciate the food the most. Anyways, let's put the birds away, and let's continue with our lesson. All right, so the next cipher we're going to be taking a look at is called the rail fence cipher. And it's not a substitution cipher. So we're not transforming the letters into something else. What we're doing is we're shuffling the letters around. So this is what is called a transposition cipher. So transposition ciphers are ciphers where the content of the plaintext is rearranged to form the ciphertext. So we see here that we've got our plaintext, HackerFrogs, and in ciphertext it becomes this. So if anybody can identify what is being done to form this ciphertext, let us know in the comments or in the chat. And it's actually not a very sophisticated way to form ciphertext in this case. Okay, so if your answer was Valenhex is correct, right? It's reversed. So in this example over here, the plaintext string has been reversed to form the ciphertext. So this is changing the order of the letters, but it's the same letters. So that's why it's called a transposition cipher. So we're going to talk about the rail fence cipher over here. In the rail fence cipher, we form the ciphertext by zigzagging the plaintext across a grid with a specific number of rows. These are called rails, and is otherwise known as the key. So in the case where the plaintext message is The secret message is HackerFrogs rule, exclamation point. Then the ciphertext message would be encrypted using this message. You would go down and then up. Well, you would zigzag down, up, down, up, down, up, down, up, down, up, until you finish the message, and then you copy the message line by line, and then write it down as this. So you'll notice that the length of the plain text and the length of the ciphertext are exactly the same. It's just that the letters have been moved around. So if we have the ciphertext and we know the number of rails used, which is the key in this case, then we can decrypt the ciphertext. So I've got an example over here. So I was just playing around with this this morning, and if we know that we can actually demonstrate this. Just a second. Let me go further down. Okay, so say we have got like a very simple ciphertext, a very simple plain text like this is secret, and we're going to say that we're going to use, let's say we're going to use 4 rails in this case. So what we would do is we would create a little grid over here, and let's copy this. So we've got a grid, and we want to create 4 rails. These are the 4 rails. And the first thing we do is we put the first letter of the ciphertext in the top, and then we zigzag down and then up and then down. So T, and then diagonal down, H, diagonal down, I, diagonal down, S, diagonal down, space, and then I, S, space, S, E, C, R, E, T. Okay, so if we take this message over here and then we copy it over, hold on, it would be T, S, E, H, space, I, space, R, T, I, space, S, C, S, E, like this. Wait, is that too many characters? Hold on. T, S, E, H, oh. I space R. Anyways, this is how you would form the ciphertext in the case that we're using the rail fence cipher. Okay, so let's go ahead and do the challenge. So this is PicoCTF rail fence, and the link for the challenge is going to be over here. Okay, and I will provide the link in the chat. Let's go over to PicoCTF. Okay, so what is this challenge? So this is the rail fence challenge. It's a medium level challenge from the cryptography category from the PicoCTF 2022 event. So it says a type of transposition cipher is the rail fence cipher, which is described here. So they've got a little link to a Wikipedia article. So here is one such cipher encrypted using the rail fence with 4 rails. Can you decrypt it? Download the message here, and it says put the decoded message in the PicoCTF format. So before we can submit this flag over here, we need to wrap it up in the PicoCTF flag wrapper, which is this. whatever we find is going to take the place of the variable here, decoded message. So download the message here. They've got a link. We're going to copy that. Then we're going to go over to our PicoCTF web shell. So in the PicoCTF web shell, we're not going to save this. Let's delete the cipher.txt file and then download the new file. So the new file is going to be wget space and then paste in the file location, which ends in message.txt. After that, hit enter to download the file. And then let's take a look at the file over here, message.txt. Okay, so this is the content of the ciphertext string. So we can copy this, and I'm going to show you the automated way to solve this challenge. So we can go over to any Google over here, and one thing about the rail fence cipher is that it's also known as the zigzag cipher. So if we were to Google up something like zigzag cipher, then we would see in here that the first result in Google is for the decode.fr site. So rail fence zigzag cipher. So we can click on that. And then we can paste in our ciphertext here. So if we have the ciphertext and we know the number of rails, and we know the number of rails because it tells us in the challenge here, it's got 4 rails. So over here, we're going to specify that the key number is going to be the number 4. So after that, we can click on decrypt rail fence. And we're going to see that this is the flag over here. It actually shows you in the rail what it would look like if you were to encrypt it using this method. And it says that the flag is here. So where does the fence begin and end? And then some numbers over here. So what we want to do is we just want to copy this portion. This is the flag content, not this portion over here. So copy here from the beginning of the W until the end with the 7. Copy that, and then go back to the PicoCTF website. So in the flag submission field, paste in your flag, but you're going to wrap it with the curly braces. And in front of the curly braces, you're going to type in the word PicoCTF, just like this. So if anybody who's wondering what the complete flag looks like, it looks like this. I've pasted that into the chat, and click on Submit Flag. And then you're done. Of course, you could do this. You could do this manually. It is a big pain in the butt to do this manually, but you could do it. So what you would do is you would, let's create a little nano file here. So we're going to nano the message.txt. And we know that this is the ciphertext. So we know that there are 4 rails. So what we would do is we would create a grid that has 4 rows like this. So we know that we know that T is the first letter, so we would put T at the beginning, and we know that what we need to do is we need to isolate which of these letters go in which of these columns, and we would need to find out how long this string is, and we can actually find out. let's see, over here, we can echo it out, and then we can pipe it into word count, and it's going to tell us how many characters this this string has. So it tells us it has 57 strings. We know that for each one of these rows, so over here, for each one of these rows, the number of letters on the very top row and the very bottom row are going to be much fewer than the number of characters that are going to go on these middle rows over here. So the middle rows, they're going to have roughly the same number of characters. And what was the number of characters for this? One more time. So this was 57 characters. Okay, so if we have 57 characters, we know that the first row and the second row, or row 1 and row 2, row 1 and row 2 are going to have one-third of all of these characters. So we have to take the number 57 and divide it by 3. And what is that going to be? Let me pull up my calculator. Okay, so 57 divided by 3, 19. So these, the top row and the bottom row, are going to both have 19. Are going to have 19 characters each. If we divide this in half, let's say that the top row has 10 and the bottom row has 9. Well, I mean, we could we'll split the difference. If for some reason it's not accurate, then we'll change it around. Okay, so row 1 has 10 characters. Row 2 has 9 characters, and rows 3 and row 4 are going to have, well, 57 minus 19. Hold on. D7 minus 19, 38 divided by 2. So they're going to have 19 each. I should have known that. Anyways, this is going to have 19, and this is going to have 19. So we would say that we can divide this into the first 10 characters, and then the second 19 characters, the third 19 characters, and then the last 9 characters. And then we would go and create a pattern with the zigzag over here. It's very slow and very tedious, and that's why I'm not going to go over it right now. But what we are going to do is we're going to skip on over to our last cipher of the day. And the last cipher is this is another type of transposition cipher. And let's learn more about this transposition cipher by working through the challenge. So inside the challenge, they're going to talk about what the encrypting method is for the cipher, and it will become apparent how the cipher works when we take a look at it. So just a second while I grab that link. Here you go. Okay, so this is the transposition trial challenge. It's a medium level challenge from the cryptography category from the PicoCTF 2022 event. The description says, our data got corrupted on the way here. Luckily, nothing got replaced, but every block of 3 got scrambled around. The first word seems to be 3 letters long, and maybe you can use that to recover the rest of the message. So we know that there's something happening to this message for every third character. And they've got a link over here. So what we need to do is we need to copy that link and then go over to our web shell And in our web shell, we can just get out of here, don't save this thing, and let us get rid of the message, and then download the new file. So the new file is also called message.txt. We're going to download that, and then we're going to read this. So this is a pretty long string over here, and it actually looks like it's very easy to see, to imagine that there's a flag in here because they've got a pattern that looks very similar to PicoCTF flags. So let's go ahead and use nano to take a look at that file. So nano message.txt. So we know from the challenge description that something is happening for every third character in this message. So what we can do is we can separate this into blocks of 3. So for every block of 3 characters, we're going to isolate it. Okay, so after we've done that, we have a bunch of different little blocks of 3 characters, and the description here says, every block of 3 got scrambled around. The first word seems to be 3 letters long. Okay, and maybe you can use that to recover the rest of the message. So if we take a look at what's happening over here, so if we take the letter T and then we move it over to the front of the block, then we have a word. So this is the word the, and then we take this space and we move it around to the beginning of the block. So we already have a message starting to form over here. So all we need to do is adjust for every third character over here, we need to shift it over to the beginning of the message. So we're going to do that. So the I goes over here, the P goes over here, the O goes over here, the F, the capital R, the number 5, the number 5, the number 6, the number 5, the letter X, the letter N, the letter V, the letter A, the letter F, and the number 7. Okay, so after we've rearranged all of these blocks, we can start putting the string back together again. And this is going to give us our finished flag. Okay, so this is the value of the flag. All we need to do is copy it and then go back to our PicoCTF challenge. So in the PicoCTF challenge, paste in the flag and click on Submit Flag, and it says it's incorrect. Oh no, it didn't. No, it's not incorrect. It's just that the server's not responding. Okay, let's try submitting the flag one more time. Okay, so that was the correct flag. Great. Okay, so let's you know what? Before we finish off today's lesson, I'm very interested in figuring out what I'm getting wrong over here. So I'm not afraid to admit that that I'm wrong. And in this case, we were having a bit of trouble with the first challenge. So the first challenge was the Vigonair one, right? Looks like PicoCTF is not being very responsive. Maybe I can get the link from the chat. I think I can. This should be it. Oh, PicoCTF. You know, I really like PicoCTF, but it's a very popular website, and that's why sometimes the servers are not going to be very responsive. But that's fine. Okay, so the key is Scilab, and this is the message. Let me just copy this. I'm going to try asking the AI why I'm not getting the correct output over here. So let me not save this, and then delete that message, and then download the new message. Okay, so let me try asking. Oh, DeepSeek is a very popular AI these days. I'm trying to use the Vigenaire cipher to decode this string with the key Scilab. I looked up the ciphertext letter R and the key letter C, and I got the resulting letter of, let me take a look. So R and C, yeah, so this comes out to T. Oh, it looks like, hold on, I need to do a little ban. So T, wait, R and C, T. But that's incorrect. What am I doing wrong? Okay, can the AI tell me what I'm doing incorrectly? Okay, align the key with the plain text. Repeat the key as necessary so that it matches the length of the plain text. Convert letters to numbers. Convert each letter in the plain text in the key to a corresponding value. A equals 0, Z equals 25. Add the numbers. Add the numerical value of the plain text letter to the numerical value of the corresponding key letter. Take the result modulo 26 to wrap around the alphabet if necessary. Convert back to letter. Convert the resulting number back to a letter. Apply these steps to your example. Okay. So align the key with the plain text. Okay, we've done this. Let's focus on the first letter. Plain text letter R, 17 in the alphabet. Key letter C, 2 in the alphabet. So we add those together, and then we modulo by 26, and then we get the result of 19. We convert that to a 19 corresponds to T. So the first letter shouldn't be T. Okay. All right. So the plain text string for this challenge is, it was PicoCTF something something, right? And I got it from over here. Okay, so what does it think of this? Do you think it's going to answer? No, it'll probably answer, but I wonder if it'll come to a conclusion that I like. So the reason why it's taking such a long time to answer is because it probably doesn't get questions like this. And as far as large language models like AI chatbots are concerned, the more often the LLM sees questions, like the question that you ask inside of its training data, the faster it's going to return an answer. But if it doesn't have an example to pull from, then it's going to take a long time to answer those questions. Okay, so let's go through the process. So one thing that that is different about the DeepSeek LLM model as opposed to chatbots like ChatGPT is that DeepSeek usually goes through its process for finding an answer, and that usually makes the answers that it provides more accurate. Okay, so let's encrypt the first few letters as an example. So plain text C and C right, so that gets so plain text 15 plus 2, 17, mod 26. Okay, that is 17. So that does correspond with, I wonder what I was doing wrong with in the decryption process. Okay, so explanation of your issue. You mentioned that you looked up the ciphertext R and the letter C and got T, but that was incorrect. This is because the plaintext letter is P, not R. What? No. No, 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 no. No, I'm trying to decrypt. Okay, well anyways, we've run out of time for this particular lesson. If you have an answer for why it wasn't decrypting properly, let us know in the comments or in the chat. But anyways, let's finish out today's lesson. Looks like DeepSeek wasn't able to give us a satisfactory answer. Okay, so what did we learn in today's workshop? We learned about the Vigenère cipher, and the Vigenère cipher is a type of symmetrical substitution cipher where each character is substituted according to its relation to a key, which is a word or a phrase. And we also learned about the rail fence cipher. The rail fence cipher is a transposition cipher where the plaintext contents remain the same but are rearranged according to a specific system. So this is the system where we go up and down diagonally on a grid, and then after we've finished, we take all of the letters from these rows and we put them all together to form our ciphertext over here. So all right, so what are we going to be talking about next week? Sorry, not next week, next session. In the next HackerFrogs After School Cryptography workshop, we'll take a look at an important concept for cryptography, the XOR math operation. So this is an operation where we turn everything into bits, which are basically binary representations, and then we apply a certain operation on them to get a new result. And it's actually kind of fun. Well, I think it's kind of fun. So stay tuned. Next time, we're going to be exploring the XOR operation for cryptography. But until next time, catch you later. But that's going to be that's not the end of today's stream. It's just the end of this this segment of the stream, and we're going to be doing something a bit different next, and we're going to be learning about x86 assembly language. All right, so let's go ahead and start that. So for everybody who's wondering, we're going to be using a certain website to take a look at x86 assembly, and it is called, find a new browser tab, it's called asmtutor.com. So we're going to be starting from lesson 1 over here, and if you're interested in taking a look, it is at this link right here. Okay, so what we're going to be doing today is we're going to be writing the basically the most simple program that we can using the x86 assembly language. And the type of assembly language that we're going to be writing today is the NASM assemblers language. But we're getting a bit ahead of ourselves. Let's talk a little bit more about this. So the reason why I want to learn x86 assembly is because I want to use it as a method of understanding what's happening inside of binary exploitation challenges. So these are challenges where you have to understand what security vulnerabilities are happening inside a program, and you can take advantage of that if you understand the instructions that are going on inside the program. So we're going to be learning how to code in x86 assembly language in preparation for learning binary exploitation. So you can do binary exploitation if you don't understand how assembly language works. It's just a lot easier if you do understand how assembly language works. But and that's why we're learning about it. So we're learning about x86 assembly. This is an assembly language that is specific to the x86 processor. So there are a lot of different there are a few different processors that are being used in different computer devices these days. There's x86, there's ARM, there's oh gosh, what are the names of these other processors? But x86 is probably one of the most common in computing devices, especially like PCs. PCs very often use the x86 family of processors. But we're going to be learning how to code in x86 assembly language, and the specific assembler that we're going to be using is the NASM assembler. So NASM stands for Net Wide Assembler. And this is the, I guess this is the logo for the NASM assembler, the Net Wide Assembler. And the specific assembler we're going to be using is NASM, Net Wide Assembler. An assembler is a program which converts code into a working binary executable. So if you're working with assembly code, you have to assemble it. So you've got the code file, and after you've finished writing the code file, you want to use the assembler program to make it to turn into an actual program. So in order to code an assembly, we need to understand the concept of memory registers. So memory registers exist on your processor chip, and they're storage locations that contain data required for process execution. So memory registers are where the data sits before the instructions are run, and we have to understand a little bit about memory registers in order to code in assembly. So thank you very much for following Nether Diamond. Nether Diamond, thank you very much, and welcome to the HackerFrogs. Why don't you have one of these? It is a Hack the Planet. Hack the planet! Hack the planet! Shut up and get in. So before we get underway, I'm gonna make a little disclaimer over here. I am not an expert in anything that we're going to be talking about today. I learned a little bit about assembly because I've worked through a few of the exercises on this asmtutor.com website. I'm not a person who knows a lot about assembly. I'm trying to learn about assembly through teaching it, and I need to look up. I'm trying to understand better about these assembly language concepts by going through these exercises and doing these presentations. So we're not going to go in depth with what the memory registers, what exactly the memory registers are, but what we need to understand is that the assembly program, when we do our assembly programming, we're going to be writing data to these 4 registers over here. So in the Hello World program, they're going to be referencing these 4 memory registers. They're basically locations where we can put our data, and these are the EAX register, the EBX, the ECX, and the EDX. So we can basically think of them as the AX register, the BX register, the CX register, and the DX register. So for our Hello World program, we should understand that we need to write information into these registers before executing the system call instruction, which prints the message hello world to our console. So these are all, we need to set up these registers before we can execute our instructions. Okay, So we're going to be taking a look at the assembly code, and the assembly code is made up of 3 different sections. So before we take a look at the code, we're going to talk about these sections. And the 3 sections in the assembly code files are the .data section, the .bss section, and the .text sections. So the .data section, this is going to store initialized data, such as constants and variables. So when we're working with our Hello World program, this section is where we're going to store the string that we're going to be printing. So our Hello World string, we're going to store it in the .data section. And the MSG in the code over here, it acts as a reference or a variable name for this string. So this doesn't necessarily need to be named MSG. We could just type out the whole word message, or we could name it something else. It's just a pointer that points to the contents of the variable over here, which is the hello world string. And the 0AH over here, this is basically a new line. So this is ASCII code. So 0A is the hex form of the new line character, and the H at the end indicates that this should be read as hex. So this is a hexadecimal number. So it creates a new line after the message is printed out. So it's hello world and then new line. This is what this means. So the DB, in this case, it stands for defined byte, and this is going to reserve a sequence of bytes in the memory. So we need to make sure that there's enough room in the memory to store our string and the new line character over here, and that's what the DB in this code does. Okay, so there's actually no .bss section in this hello world code, but we're just going to talk a little bit about this section in assembly code for the sake of completeness. So it's used to store uninitialized global or static values. So this could be a place where variables that are defined during program runtime are put into, and but in this case, we'd have no use for this section. So the last section is the most important section in the code, and this is the .text section. So the .text section of the assembly code contains the program instructions. So the actual program instructions are in this section of the code here, .text. So the .text section starts with this global directive right here, and it points to the object that is going to have the instructions inside of it. So in this case, it is _start. So it basically tells the program where the entry point for the program is. So global _start says that the instructions start with this object right here, _start, and then the instructions occur under that. So it defines _start as the entry point for the program. So we've got 2 different types of instructions in this hello world program. There's the move instruction and the int instruction. So we've got move, then the name of a memory register, and then some value. And we've got int and then a number over here. Let's talk about these 2 instructions and how they're used inside of the assembly code. So the move instruction. So the syntax for the move instruction is the word itself, move, and then the destination to where the data is going to go. So move into the destination this information right here. So when using move, we specify the destination first and then the value to be moved there. So we've got this instruction here, move edx 13. So in this case, we're going to write into the edx register this value right here, which is the number 13. So 13 goes into the edx register. And the other instruction that we're going to see in the code is going to be the int, the int instruction. So int stands for interrupt, and the int instruction is used to trigger software interrupts. This allows the program to request services from the operating system. So if we want, so the program is going to use specific function calls from the operating system inside the code. And in the hello world code, int 80 hex. So this is a hex digit, 80. It performs a Linux system call, otherwise known as a syscall, and because the value 4 is written to the EAX register, Linux performs the write system call, which prints something to the console. So before we run this instruction, int 80, we need to put other values into the registers, specifically the EAX register here, and it's going to take what is in that register, and then based on that, it's going to run an instruction. Okay, so let's get to it. So this is lesson 1, and we've got all this code over here. So everybody, you can go ahead and go to the page and then scroll down to the section that has all the code. If you don't have access to a Linux system that you can use to compile the code, that's fine, because I've found a little workaround, a little website over, where is it? Let me find it again. This one right here. Okay, let me get the link. Okay, so everybody, this is the link for the online compiler for NASM. So after you arrive on this page, there's already going to be a bunch of assembly code here. We don't want this code, so just scroll down to the bottom and then highlight everything and delete it all. So delete all the code there, and what you're going to do is we're going to go over to the ASM Tutor lesson 1, and we're going to copy all the code. So copy all the code from there, go over to the onecompiler.com website here, and then paste in your code. Okay, so so inside these comments, so inside of these ASM files, this is assembly language files, anything that comes after a semicolon over here, that's going to be a comment. So this isn't regular, well, this isn't regularly how you do comments inside a code, but I guess assembly language is unique. So you can see here that there are all these comments here. It says it's a hello world program. It gives you the instructions to compile the program. So you have to run the NASM assembler on it first, and then you have to use LD to link the file with the libraries. And the last thing you do is you actually run the program over here. So we've got 2 different sections in here, and the code is going to be in the text section. So the first thing we see is the data section. We're going to define this, and we're going to put the hello world string along with the line feed in here, and that's all there is to the data section. So in the next section, the text section, we're going to define where the entry point of the program is, which is this one over here, _start. And under _start, we're going to actually have our code. So what's happening in here? Let's take a look. So they've got a bunch of comments over here, and they tell us what is happening for each one of these instructions. And the first instruction is to move into the EDX register the number 13. So it says here this is the number of bytes to write. So the program needs to know how many characters to write when the write instruction is called. So there's 1 for each character in hello world. So this is going to be 13 bytes. This is actually 12 bytes. This is 2, 4, 6, 8, 10, 12. This is 12 bytes. But the new line character here also counts as a byte. So that's 13 bytes. So we need to put that inside of one of the memory registers. In this case, it's the EDX register. The next instruction is going to move the contents of the message into this ECX register. So move the memory address of our message string into this ECX register. So this string right here gets moved into ECX on line 15 here. So the next instruction on line 16 is the next two instructions are going to be combined with the system call over here. And the first thing is we need to tell where we're going to write to when we do the system call. And the number 1 is associated with the standard out, the standard out output in Linux. So we're going to put the number 1, which is standard out, into the EBX register. And the last thing we need to do before we do the system call, is to put the number 4 into the EAX register. So this one's very important. Before we do any system call, we need to put one of the opcodes, one of these system call codes, into the EAX register. And in this case, opcode number 4 is associated with the system write command. So there's a bunch of these different Linux system calls, and I found this, where was it? This handy dandy little chart that tells you what the different system calls are. So we've got the numbers over here, and I think I can make this bigger. Make it bigger. Okay, so we've got the functions associated with the numbers. So we've got the exit function, number 1. This is actually pretty important. We're going to be learning how to use that pretty soon. We see that the number 4 is the write function. So this is what lets us write something to the console with our program. So this number 4 has to be put into the EAX register before we run the last instruction. And the last instruction basically says do the system call. So int interrupt ADH. This is the instruction that that makes Linux do the system call, and then all the instructions in here are triggered. Okay, so let's go ahead and run the program. So if you have any questions about what's going on, I might not have the answer, and if I don't have the answer, I'll be looking it up. But feel free to ask any questions that you have. All right, so after we've pasted in our instructions here, we can click on Run, and it'll compile the program and then run it. So when we do this, our output is going to be hello world, but then it also says command failed, timeout. So if you know the reason why the program crashed after it printed out hello world, let us know. But we'll be talking about that in just a little bit. Okay, so let's try compiling this ourselves on our Kali Linux box over here. So let's go ahead and we're going to make a file called helloworld.asm. Okay, so from there we're just going to get our code here. And paste in our code. Okay, and then we're going to save the modified buffer. Save this out. Ronan1 says we are the null terminator. Yeah, that's right. Well, I think what you're talking about is we didn't terminate the program, so we didn't exit the program correctly. And MC25 says first thought it was no cleanup and crashed. Yeah. There wasn't any we didn't exit the program cleanly after we wrote our code, and that's why the program crashes at the end. But we'll come to that in just a little bit. Let me just demonstrate how to compile this. So we got hello world.asm. It's all actually the instructions are here. So it says compile with this command here. So nasm format elf hello world.asm. So when we run that command, it's basically compiling the instructions in this file, and it's going to create another file called hello world.o. So this is an object file, and this is not a program that we can run. The thing we need to do before we can run the actual hello world program is to link it. We have to run our linking tool first. And you're going to see here that it gives you that instruction as well. So this is the instruction we need to do. So LD, and I think we need to, this specifies that this is going to be a 32-bit program right here, elf i386. We're going to give it the hello world.o object file, and we're going to output it to a file called hello world. Okay, so let's go ahead and do that. So when we run this command, the resulting hello world program here, this is an executable file. So if we run file on it, we're going to see that this is an ELF 32-bit executable. And when we run the program, whoops, it's going to print out hello world, but then it's going to give us a segmentation fault. So segmentation fault means that the program tried to run a command that didn't make sense, so the program crashed. So the program crashed, and let's take a look at why the program crashed. That's going to be in lesson number 2 over here. So lesson 2 is talking about a proper program exit. So after successfully learning how to execute the system call, we need to learn about one of the most important system calls in the kernel, which is sysexit. So after we ran the hello world program, we got a segmentation fault. So computer programs are can be thought of as a long strip of instructions that are loaded into memory and then divided into sections or segments. So the general pool of memory is shared between all the programs and can be used to store variables, instructions, and other programs or anything else. Each segment is given an address so that the information in that section can be found later. To execute the program that is loaded in memory, you're going to use the global label start to tell the operating system where in the memory our program can be found and executed. Memory is then accessed sequentially following the program logic, which determines the next address to be accessed. The kernel jumps to that address in the memory and executes those instructions. So it's important to tell the operating system where it should begin execution and when it should stop. So in the first lesson, we didn't tell the kernel where to stop execution. So after we called the syswrite, the program continued sequentially executing the next address in the memory, which could have been anything. So we don't know what the kernel tried to execute, but it caused it to choke and terminate the process for us instead, leaving us the message of segmentation fault. Calling sysexit at the end of our programs will mean that the kernel knows exactly where to terminate the program and return memory back to the general pool, thus avoiding the error. Okay, so the next thing we're going to do is we're going to add the instructions to exit to our program. And so the program is very, very similar to the first program, except we've got this extra section over here. So we're going to move into the EBX register the value 0, which is to give like a exit without errors. So that's the 0 status. And then we're going to move into the EAX register the instruction for 1, and 1 in the Linux kernel is the system exit kernel opcode, and then we do another system call, the int80. So let's go ahead and copy that, and let's go over to our online compiler, and add that to the end of the code. So all we need to do is put these instructions at the end of the code that we were running before. So remember when we ran this before, it says command failed, timeout for hello world. That's fine. Now that we have these instructions, we should be able to N1 No, thank you very much for redeeming the Stellar J. Thank you very much. And welcome to the stream. You know what? Let's give you a fun little redeem as well. This is one of my favorite little memes from way back when. It's the Nancat. Okay, so what's different in here? So after we run the first system call to write hello world, we move a couple of more instructions into the memory registers. So we're going to move into the EBX, the status 0, which is no errors, and then we're going to move into the AX, the system code, the kernel opcode for exit, and then we're going to run that command, and that's going to shut down the program. So if we just hit run, it's going to give us hello world, and it's going to not give us any errors. So that is exactly what we want. Okay, so let's go ahead and try doing this in our own compiled version over here. So we've got ads running on Twitch. Okay, so while the ads are running on Twitch, we're gonna take a little break, and for everybody on YouTube, we're also going to insert an ad, just so we don't have ads running randomly. So YouTube ads in 3, 2, 1. Okay, and let's take a look at some birds. This is my favorite video. These little baby birds having a bird bath. So please enjoy this while I have a little sip of water. Just a second. Love these little birds. So this footage was taken in, actually, I think.
What are you? I'm System Root.
I'm System Root. Thank you very much. And N1. How do you pronounce your name? N1 No or Ni No? I'm not too sure. Let me know. Let me know in the chat, and I'll pronounce your Nino. Okay, great. Thank you. Thank you for letting me know what your name is. Okay. So let us go back to our lesson. So we've got the extra little bit of code, and we're going to insert it into our helloworld.asm file. So all we need to do is add the instructions. Whoops, over here. So it looks like we need to do some indentation in this in assembly language as well, so we can go ahead and do that. Okay. So we return 0 status on exit. It says no errors. And then we invoke the system exit, and then we run the system exit with the int 80 instruction here. Okay, so all we need to do is save the file, and then we're going to recompile the program. So Juvenile asks how to do CTF. Juvenile on YouTube, hello, nice to see you here. How much experience do you have with technology? Have you done programming before, or have you studied computer science? How much do you know? Xerox Tiberius has just rated the channel with 89 viewers. Nice to see you, sir. Hello, Juvenile. Hello, Raiders. We're just doing a little lesson on how to code with assembly language. But welcome, Raiders, and welcome in. And Xerox Tiberius was probably doing Cyber Mentoring Monday. That's what happens on Monday, right? Over at Tiberius's channel. And let us know what you were covering on Tiberius's channel. because I am very interested. Okay, so we're just trying to figure out how to write the Hello World program in x86 assembly. Let's see, Rebel CS says yes, okay, and Juvenile says I experienced in cyber for like 6 months and winning CTF competitions on my campus. I'm third semester and I can code, but I aim for better competition and I hope I can win them. Okay, so you did cyber security stuff for 6 months and you did a CTF competition. Okay. All right. So you know what? I have a playlist over on YouTube that goes over a lot of different CTF challenges. So they're all challenges from the PicoCTF website. And let me see if I can find that. So PicoCTF challenges. So let me get the link for this. And thank you very much for following Koni Telka Mike. Thank you very much for following on Twitch. You're now HackerFrog. So Juvenile, why don't you take a look at this playlist over here? It's a bunch of different CTF challenges, and hold on. So in these CTF challenges, these are walkthrough videos. If you want to do the CTF challenges yourself, you can do them. And inside of each of these challenges, we have links that go to where we can find the challenge, and you can do it yourself. And this is what I recommend. I recommend you try to do the challenge yourself, and if you can't do the challenge, you can watch the walkthrough video, and you can figure out what is going on in the challenge. So the beginning of the playlist is very, very simple and very easy, and it becomes more difficult the further you go inside the playlist over here. It's got 84 different videos, and hopefully you can learn some interesting things from solving these CTF challenges. But yeah, that's my recommendation if you want to get into CTFs. All right, so everybody, if you're wondering what we're working with today, this is the site that we're looking at. So it's the asmtutor.com website. There you go. Juvenile says, thank you very much. I want to get advanced in Pwn or Rev. Do you suggest learning about memory layout and reading assembly language? Yeah, you know what? This is actually good for you if you want to learn about reverse engineering and binary exploitation. You should understand how to read assembly language. You don't necessarily have to do a lot of coding in assembly language, but you should understand how assembly language code works and what happens when you're looking at the disassembly instructions inside a program like Ghidra. Okay, so let's go ahead and recompile the program. So we made our modifications to the Hello World assembly file there, and then we can run this program to compile it. So we're going to assemble the instructions using the NASM program. We're going to make an ELF binary from helloworld.asm. So we do that, and then we get a helloworld.o file, and then we need to link it using this command here. So LD on the helloworld.o file, and we create a new binary called hello world. So after we do that, hello world is here, and we see it is a 32-bit executable. So when we execute the program this time, it just says hello world and it exits properly. We don't get an error message. Okay, so the reason why we're learning about assembly is because we want to learn how to do binary exploitation, and we want to learn how to do reverse engineering as well. But so let's take a look at what happens inside of the Hello World program by using a disassembly program. So thank you very much for following Shabala. Thank you very much. And you are now HackerFrog. How about you have one of these?
Hide the planet! Hide the planet! Shut up and get in.
Okay, so what the program that I want to use to learn about binary exploitation is called Radare2, and Radare2 is actually it's a pretty powerful piece of software. It can be used for binary exploitation, reverse engineering, and some other stuff. It comes pre-installed on Kali Linux, and Juvenile says I've heard of it. Yeah, it's pretty popular in the binary exploitation scene. So you can run it by doing R2 on whatever binary you want to. In this case, I'm going to run it in debug mode, and we're going to take a look at the contents of the Hello World program. Okay, so after we do that, we say that we're inside the Radare2 program right here. We need to analyze the binary, and you do it with a number of A's. So we're going to analyze all of the symbols and the entry point and all that other good stuff. And then we're going to take a look at the functions in here. And there's only one function in here. It's called entry 0. So we're taking a look at the binary that we just compiled using the assembly instructions. And we can disassemble the entry 0 function with this instruction right here, PDF. I print disassembly function. I think that's what it stands for. And when we run it, it's going to ask us if we want to print all these lines. Apparently, it's a very long function, but that's okay. We're going to go up to the top here. Thank you very much for following Bermuda Square TW. Thank you very much for following on Twitch. And why don't you have another little... Oh, hey, do you all know this classic scene from Jurassic Park?
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
So this was one this was one instance where you could use Unix to protect yourself from dinosaurs. Who knew? Okay, so what's going on in here? So we've got all of the disassembly instructions for the Hello World program that we did, and we've got the memory addresses. So we've got move into the so these instructions aren't exactly the same as the instructions that we compiled, but they look very, very similar. So what's going on? So we're moving into the EDX memory register, this value over here. So it's hex D. What is D again? D is I guess this is 13. Right, this is the number 13. And remember that in our code, we need to specify the number of bytes that we're going to be that we are going to be writing out. So this is this instruction over here. So the next instruction is move into ECX, the message. So ECX is the memory register where we're going to move our variable into, and this is the variable hello world. Okay, so after that, we're moving into EBX, the number 1, and the number 1 is, what was the number 1 again? The number 1. What was this number 1? Number 1 is for standard out. Right. So we need to specify what we're going to write to, which is Linux standard out. Which is, I think that should be write, shouldn't it? Or is it write and read? I'm not completely sure, but thank you very much for your input, MC25. And then the next instruction is move into EAX, the value number 4, and we remember that the value number 4 is the Linux opcode for system write. So after that, we do int 80, which is the system call. So here it says 0x80, but in the code it's 80h. They both mean that this is a hex number. So after that, we move into EBX, the number 0, which means it means 0 errors, right? Or successful. And then we move into EAX, which has the Linux system calls, the number 1. And the number 1 is the opcode for system exit or program exit. Which one is it again? That is terminate the current process. So that's the number 1. So after that, we do int80. And I don't know why there are all of these instructions after this last int80. But if you know, let us know in the comments or in the chat, because I have no idea why the program is so long. It just keeps on going like this. But that's how you would take a look at the contents of the Hello World program. So inside of Radare, we can just exit out of here, and this is probably this is one of the simplest programs you can create using assembly. Let's take a look at what the next lesson is. I wasn't thinking past the first couple lessons, but let's see what the third lesson is over at NASM. What's it? ASM Tutor. Okay, so lesson number 3 is calculating string length. What if we wanted to output something that we didn't know the length of, like user input? Oh, okay. So what I wanted to point out is that you can learn a lot about assembly language here, and even if x86 assembly for Linux is not your preferred device to be writing programs for, it's still going to teach you a lot about basic assembly language syntax and what the code looks like. You might not exactly be doing programming with x86 assembly for Linux, but it's still a pretty good place to start, especially because when you're doing binary exploitation exercises, they deal a lot with Linux binaries that are written in x86. So it's going to help you a lot. But anyways, let's finish out today's lesson. And actually, here's another thing. I wanted to point out Soko TSoko27. Thank you very much for following on Twitch. Why don't you have one of these? How about a frog song? This sounds kind of like a frog. Thank you very much, TSoko27. Okay, so Ronan says a code cave is a series of unused bytes in a process's memory. So was the stuff that we saw in the program an instance of the code cave? It's not something I'm super familiar with. I'm not a programmer. I only learn about programming to help me do hacking, but I do think that programming is super interesting. Okay. You know, this is something we can ask the AI. Maybe if we let me just try that again. Okay, so we're gonna analyze the binary, and then we're take a look at the function. Then we're going to do the disassembly at the entry 0 function, and I'm gonna copy a bunch of output over here. I'm gonna ask the AI what it thinks about this. Just because I want to know. Ronan says you can inject a backdoor in this empty space. That's exactly what they intended, right? That's got to be it. Let's ask ChatGPT. Maybe ChatGPT knows. How about ChatGPT? Why is there so much extra output at the end of this Hello World program? Okay, the extra output at the end of the Hello World program is likely caused by extra null bytes in the text section after valid code execution ends. Extra null bytes? How did we put extra null bytes in the text section? So we print hello world, okay? This prints hello world to the screen, and then we exit the program, right? Why is there extra output? So execution should stop. However, the disassembly shows a sequence of null bytes over here, right? So it says, this happens because the compiler linker padded the section with zeros. Oh, okay. Rupert VB says, what is the line halfway up the AFL as you scroll? Very nice insight, says Juvenile. So Rupert says, what's the line halfway up the AFL as you scroll? So halfway up, there's a line. Oh, this line right here. So this is the line that was created by the Radare 2 program. So the Radare 2 program has it's got these lines that I think it's trying to encapsulate the instructions over here to organize it. I think it goes all the way to the end over here. So over here, Radare 2 tries to organize code that's related to each other. And I didn't notice this, but it's got all of these extra instructions over here after the program ends, and I have no idea what it's doing. I'd like to figure out what all this stuff is doing. Maybe I'll figure it out after I've studied assembly language some more. But yeah, this is the backdoor code. This is the code that's hacking my computer, right? It's that's got to be it. Yeah. But it's really funny because you expect that this program would be super simple and that it would end right after it runs its instructions. So we would expect that the program ends right here after we exit, but it does not. There were some jumps, right? So I'm not super familiar with assembly instructions, but there are some jumps. So all of these J instructions, they're jumping to different places in the code, and I'm not sure what exactly is going on. Mining crypto exposed. Yeah, that could be it. Actually, wait. You know what? Maybe I should feed this into the AI and figure out what's going on. So I don't know if it's well, ChatGPT probably isn't going to tell us that that is mining crypto, but what is going on in this section of the assembly? Paste that in. Okay, so what does it say here? This section of the assembly appears to be misinterpreted as executable instructions, which are just likely data. What's going on? So there's ASCII strings in the code interpretation. What? Okay, parts of it resemble readable words. Oh, okay. So we've got some strings over here that were probably created when we were adding comments and stuff. So it suggests that this section is storing symbol, table, or debug-related information rather than actual executable instructions. Some of the instructions are rarely used in normal x86 programs. So these are conditional jumps that point to locations that don't seem meaningful. So why does this happen in disassembly? So disassemblers like Radare 2 attempt to interpret everything as code unless explicitly told otherwise. if they misinterpret data sections as code, it could result in nonsense instructions. So it's possible that this could be part of a data segment or metadata. Oh, okay. So it could be Radare 2 not interpreting the instructions properly. So this could be metadata that it's trying to interpret as instructions. Okay, but yeah, that was a fun little that was a fun little journey. All right, so everybody, we're going to be doing more exploration like this because I'm getting ready to write a little course on how to do binary exploitation. Let me show you guys what the rest of this week is going to look like. So we've got a subreddit for our HackerFrogs over here. And if everybody wants to take a look at this page over here, this is the schedule for this week. So we've already done, this is today. We did our cryptography basics. We looked at some of that. We did our look at assembly language over here. And next we're going to be doing some Linux hacking over with these Docker containers. But the rest of the week, we're going to do some more cryptography basics. And then we're going to do some easy binary exploitation challenges over at PicoCTF. So we love PicoCTF because it is our favorite free platform for learning about all sorts of cybersecurity things. If you're interested, then you can go over to this link. And if you want to take a look at binary exploitation challenges before we cover them, then you can look for these easy. Oh, there are not very many easy. There are not very many easy binary exploitation challenges at all. But yeah, if you want to take a look at binary exploitation challenges, you can do so at this link. But eventually, I'd like to be able to walk everybody through most of these medium level challenges over here. But that's going to take a bit of time. But we'll be starting with our easy challenges for binary exploitation next time, which is going to be on Wednesday. And yeah, if you're interested in that, please show up on Wednesday, and we're going to be covering that. And but we're going to be moving on into our last portion of the stream now, and the last portion of the stream is going to be doing some Linux hacking. So thank you very much for following AOE King 3. Thank you. And Shabala says, hell yeah. Hey, nice to hear. Nice to hear you are excited. So if you're interested in participating with us, what you're going to need is you're going to need a Linux security-oriented version of Linux, something like Kali Linux, and then you're going to need to install Docker onto it. So after that, then you can access these vulnerable Docker containers on this site right here. It's called dockerlabs.es. So there's a slight wrinkle in doing these hacking challenges, and that's because this website is in Spanish. But you know what? If there's something that gets in the way of your hacking, you hack around it or you hack through it. So we're going to be doing a lot of Google Translate to try to help us with these challenges because some of the text might be in Spanish. So I think we left off over here, the upload machine. And what we can do is download this container and then deploy it to our Kali Linux machine. Oh, Mega failed to load? What's going on here? I hope I can download this thing. It's only 100 megabytes. Okay. All right, everybody, so we're downloading the challenge now. And after the challenge downloads, we can unzip this file and then deploy the Docker container. So we've got our Radare 2 over here. We're going to quit, get out of here, and let's get rid of this these files over here because we're done with them. Okay. So we're going to go to our Docker container in the downloads directory. We just downloaded this file over here called upload.zip. So the previous challenge we did was called Verdejo. So I'm just going to get rid of this. I'm going to get rid of that challenge. And then we're going to unzip this upload.zip file. So the name of this challenge is called upload. So that tells me that we're probably going to need to upload some malicious files in order to get our hacking done. So let's go ahead and start the challenge. We need to use this auto deploy script over here to start up the container. So we need to make the script deploy executable, and we need to run the script on upload.tar, this one over here. So we've got our Spanish over here. Estamos desplegando la máquina vulnerable. Espere un momento. So we see that the Docker container has deployed, and it says that we can access it on this IP address right here. So the first thing we need to do this, yo no sé, I do not speak Spanish, but I am learning. I'm learning a few words by doing all these Spanish challenges. So un momento is one moment. Estamos is we are, right? We are deploying the machine, the vulnerable machine. I think that's what it says. It means, you know, say means I don't know. Shabala, are you a Spanish speaker? Let us know. Let us know, because we really appreciate our Spanish speakers in chat, because they can help us translate. Okay, so we're gonna run nmap on this IP address where the vulnerable Docker container is. We're gonna run it very verbose. We're gonna run it with versioning information, and we're gonna run common scripts on it. Oh, we've got ads running on Twitch right now. Okay, so everybody, during the ad break on Twitch, we're going to run ads on YouTube as well, just so you don't feel left out. And then we're going to play some bird feeder clips. Here is a bird. I'm going to take this opportunity to have a little drink. Just a second. Okay, so this is a good opportunity to play a little bit of music. So let's play some music so that it's not just me talking into the void. How about we play some Independence War music? I really love this soundtrack. It's from a really long time ago, and it's a really old sci-fi game. Alright, if the music's too loud, let me know, and I will adjust the volume so that it is not too loud. But it is a bit loud. Okay. So Shabala says, "We back," and I'm not Spanish speaking. Well, that's okay. That's okay. We all come from different backgrounds, and we have our own personalities that we all bring to the hacking table. Okay, what's going on? So we run the nmap script over here. There's only one port, so this is probably port 80, and port 80 is basically your web server port. Music a bit loud, to be honest. Let me turn it down. Okay, let's take a look at the audio. If you still think it's too loud, let me know. It should be in the background, but not overpowering. Okay, it says upload your file here. Alright. And it's running on port 80, so we can go ahead and take a look at it. So we can go to 172.17.0.2, that's our IP address. We're going to tack a HTTP in front of it, and it says it works. Well, this is a default web page, so we should probably take a look at the source code just to make sure that there's nothing important leaked in the source code. I don't think there is. In this case, what we need to do is we need to do further enumeration on this on the web server. So how do we do that? We're going to go to our web enumeration tab over here. We're going to run a few different tools to take a look at the web server. So the first tool that we're going to do is we're going to run the dirb tool. So dirb is a pretty old web directory busting tool, but sometimes it gives us good results. In this case, it doesn't. That's fine. We're going to run the Nicto tool as well, and Nicto is a web app vulnerability scanner. Sometimes it can give us some good results, but Nicto is also a very old tool, so we might not be able to get anything super good out of it, but we run it anyways, just in case the web server is running some old software. That's where Nicto can really shine. Okay. So I'm going to try a new tool today that I've never really used this tool before, but a lot of people say that it's really good, and it's another directory busting program. It's called Ferrix Buster. So let me go ahead and look up how to use Ferrix Buster real quick. Let me look this up. Ferrix Buster cheat sheet. So cheat sheets are... Oh, okay. This is an article. I just want a cheat sheet on how to use this program. Okay, Ferrix Buster, simple, fast, recursive. So what do we got? Ferrix Buster, URL, depth, word list. Okay, this looks good. Let me. I think I know. So depth 2. So Ferrix Buster. URL, and we need to supply a word list. Word list. And we need to supply a depth. Okay, so for any of these directory busting tools, we need to supply a word list to use to check against. We're basically checking to see if there are any endpoints that match any of the words on the word list. So the default one that we usually use is going to be located on Kali Linux in user share word lists, dirbuster, directory list 2.3 medium .txt. So the URL that we're going to supply in this case is going to be 172.17.02. Let's see if it works. Okay. Oh, this is a very nice... Okay, I see why people like this. It's got nice shiny graphics over here. So we've got target URL, we've got threads, we've got a word list that we're using. Our status codes that we're going to return, all status codes, timeouts, and yeah, it's fancy. Okay, so previously I was using GoBuster, and GoBuster doesn't look this pretty, but we found an uploads directory over here, and we might as well check this out. So this has directory listing. So we can actually manually enumerate this this endpoint. So this is where we suspect we're going to find our uploaded files. There's nothing in here because nothing's been uploaded yet. And oh, you know what? You know what I forgot to do with Ferrix Buster? I forgot to give it file extensions. So we need to supply a number of file extensions that we want to search for. let's see. Okay, so we can supply -x. Options that take multiple values are very flexible. Why would we want to specify extensions like this? Well, let me give it a go. Okay, let's run the Ferrix Buster scan again, except we're gonna put some, we're gonna add some file extensions over here. So we're looking for, I don't think we need to look for PDFs or JSON, but let's see if we can look for some PHP, some TXT, some JSON, some docx. Actually, we don't need to look for docx. MC says, saying you can do them with 3 different ways. Oh, okay. Well, in that case, I just want to use my commas. There you go. All right, so we found an uploads.php. So this is probably the endpoint where we're going to be able to upload our files. So we can go ahead and check out this. We can check out this endpoint by copying it over here. This is really nice. I don't. I'm sad that I didn't. That I haven't been using this program. I should really use Ferrix Buster more. Okay, let's go to that endpoint. Okay, so we've got an upload web application over here. So we need to figure out what we can upload. We can actually, you know what we should do? We should probably record this inside of Burp Suite. So if you can record an upload attempt inside of Burp Suite, then you can fuzz the application with something like the FFUF program. So that means I'm going to start up Burp Suite, and if you've been watching Tiberius's channel, you know that he loves Burp Suite because that is his main program. Okay, so actually, so before it starts up, I'm just going to copy this endpoint over here. Burp Suite is starting up. We need to complete. And then after it finishes loading up, we're going to go and start up the Burp Suite browser. So Burp Suite records all of the web traffic that goes between your web browser and between the web browser and the web server, and it records everything. So this is what we want to do. It sure is taking its sweet time. Okay, so it's up now. We're going to go over to Proxy, Open Browser, and that's going to start up the Burp Suite browser. The Burp Suite browser is connected to Burp Suite. That's why we use it. And we're just going to navigate to the upload PHP endpoint here, and we need to find out what kind of file extensions are accepted by the web app. So we're just going to choose a file. How about this one? Try uploading it. You know what? I thought it would be difficult. I thought we would have to try to figure out which file extensions work, but it looks like it takes anything. So that makes our work a lot easier. All right. So can I just find this file in the uploads directory? Let me check it out. I started up Burp Suite. Did I need to? Okay, so let's take a look at the uploads directory. It just, okay, it doesn't check. It doesn't check whether or not it's a valid file extension. It just uploads anything you give it. All right. In that case, we don't need Burp Suite anymore. Let's shut it down. Okay, we're going to, let's get a reverse shell PHP script. So what we want to do now is we want to upload a Well, when we're in, we'll call Mr. Scary Hacker Voice guy, and then he'll talk about what's going on. But thank you very much for reminding me, Rupert VP. Yeah. Okay. So we're gonna locate a PHP reverse shell script, and it looks like there's one over here. So we're just gonna copy it to our current directory, and then we're gonna do some adjustments to it. Permission denied. It looks like we need to do sudo with that command. I don't know why. Wait. I forgot to specify copy. Silly me. Okay. So the reverse shell is here. What we want to do is we want to upload a malicious script file. So that would be this one right here, PHP reverse shell. When the web server runs this script, it's going to give us a reverse shell connection, and that is exactly what we want. But before we can upload this file, we need to adjust a few variables inside of it. So I'm just going to use nano to edit the file. We need to edit two variables, so the IP variable and the port variable. So in this case, the port that I like to use is 443. And the IP address for our attacker system is going to be this. So this is the Docker network, and this is the IP address for our attacker machine on the Docker network. So sorry, not the Docker network. Well, actually, I guess you could call it a Docker network, but it's the Docker interface. Let's save that file. And then let's start up our reverse shell listener. So what we want to do is we want to have the victim machine make a connection to our attacker machine instead of the other way around. This is oftentimes more successful than trying to open up a port on the victim machine and then connecting to it from our attacker machine. And there are a few different reasons why that's the case, but in our case, we're going to start up our reverse shell listener with rlwrap and netcat on port 443. This means that our attacker machine is now listening on port 443 for the victim machine to make a connection to us. So let's go ahead and try to upload that file. So we've got our upload. We're going to browse. We're going to specify the php reverse shell.php file and then upload it. And there are no safeguards on this application. We just uploaded that this PHP file. This should not be the case. If this was any sort of secure application, that would not be the case. But from here, we can just go to the uploads directory, and we see that php reverse shell.php is here. When we click on it, we're going to see that the browser tab doesn't resolve. It gets hung up, and that's a pretty good indication that our malicious PHP code is running. So if we take a look at our reverse shell, it's not working. Why is it not working? Okay, I need to figure that out. Let me confirm our IP address. So this is the Docker network. Oh, wait. I put in the IP address incorrectly. Let me check. So the Docker container is on 1702. Yeah. I typed in my IP address incorrectly. Let me correct that mistake. Everybody, this is I'm going to repeat this a lot. If you make a typo, you do not get to hack. If you make any sort of spelling mistake, you do not get to hack. So please try to make as few spelling mistakes as possible. Okay, let's do that one more time. Let's upload that file one more time. Okay, and then let's navigate to that PHP reverse shell one more time. Hack the planet. Yep, that's what we do. Okay, let's look at a reverse shell now. Now we're in. Okay, so we're the www data user. We're in, so we need to call on the powers of Scary Hacker Voice Man. Just a second, I need to call the Scary Hacker Voice Man.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we break into a server, and we broke into this one. Well, Mr. Uploads Administrator, it seems like you forgot to secure your web application against arbitrary file upload. That was a big mistake. Maybe you knew about these security vulnerabilities, or maybe you decided to accept the risk. Well, you accepted the risk, and now... now we're in.
Okay, so Peanut Gamer 9 says, "Sup, Shyhat." Hello, Peanut Gamer 9. Nice to see you. And let's see, Rupert VP says the old arbitrary file upload trick. Got him. Yup, we are so in. Awesome, awesome. All right, so we're in, and we need to figure out how to escalate our privileges. So privilege escalation is basically going from a low-level user and going to the highest level user. In the case of Linux, that is the root user. So the first thing we want to do is we want to figure out which version of Python is running. There's no Python or Python 3. That's fine. Maybe we can make do with what we have right now. So let's see what users exist on the system. It looks like there are no regular users on the system. There's the only user who has a regular shell is the root user, it looks like. Okay. It's been a while since... Let's see what's in the home directory. There's nothing in the home directory. Okay. What about the web apps directory? Thank you very much for following Sirovi? Is that how you pronounce your name? Let me know how you pronounce your name. Thank you. Thank you, Sirovi. Let's see. So all we've got here is this stuff right here. That doesn't help us get privilege escalation. Okay. So there are a number of different things we can check for privilege escalation. We can take a look at cron jobs by looking at the cron tab. There's no cron tab. We can take a look at the running processes. There is Apache running on the system, but nothing, not too much else. We can take a look at... What else can we take a look at? We can take a look at SUID binaries. So we can find binaries with special permissions. And we've got these ones over here. Oh, you know what? I forgot to check if we can run... This is... Oh man, I must have... I've actually completed a lot of systems that have this specific SUID binary, actually pseudo permission. So that's the ENV binary over here. And Leo says, hello, HackerFrogs, just jumping in. Great to see you here, Leo. And yeah, how are your classes going? And welcome to the stream. We're just going to be hacking against these Docker containers for the next couple hours. Hopefully we can hack through a bunch of them, but we'll see. I think we're pretty close to the end of this one. So when we investigate our pseudo permissions on the box, we see that we can run this binary right here. the env binary, and it's basically a binary that loads up different environment variables. I think that's what it does. If we take a look at a site like GTFO bins, so GTFO bins is a great resource to figuring out if you can use specific Linux binaries to get elevated access. So you can search for whatever binary you're dealing with. So the env binary is here. We know we have sudo permissions with it. It says here that if the binary is allowed to run as super user by sudo, it does not drop elevated privileges and may be used to access the file system, escalate or maintain privileged access. All we need to do is run the binary like this, with this argument here that starts up a shell, and then because it's running as sudo, it's going to give us a root shell. So we can just copy the command, sudo env bin bash, and we're going to have complete access to the system. Okay, so when we ask who am I, it says we are root. We no longer have a prompt here, but that's fine. We can still run this. So we're now root, so we get to run this redeem.
What are you?
I'm system root.
Okay, so there are no flags on these systems here, but what we can do instead is we can do a classic hacker thing, and we can deface the website. So we can deface the system, and we deface the system by basically leaving a little graffiti tag. So we're going to echo HackerFrogs rule, and we're gonna write it to graffiti.txt. Okay. After that, we see that we've got our graffiti.txt that is owned by root. If you read it, oops, that's not how you spell. That's not how you spell graffiti. How do you spell graffiti? Okay, HackerFrogs rule. Okay, so we finished the system. Awesome. All right, let me take some quick notes. It's not much of a write-up, but I'm trying to do a little write-up for each one of these machines that I do on Docker Labs. And this one was called was it called upload? Let me check. This one was just called upload. Okay, let me write up my notes real quick. So, documentation is very important when you're doing information security, cybersecurity, or if you're just hacking in general. You want to keep notes. Graffiti double F single I. Thank you very much, Cybernerd Dante. And let's see. There's only one port open, and that's port 80. There's a upload directory and an upload.php page. What else? So there's no file upload restrictions on the web app. So we just upload php reverse shell.php and go to town. Smiley face. Let's see. Once on the box, we have sudo permissions with the env binary. Sudo env bin sh finis. Okay. Digital Warhead says, have you used Notion for notes? Yeah, I have used Notion for notes. Mostly these days, whatever notes that I take, I put up on GitHub. So GitHub is a pretty good place to keep your stuff. if you want, you can make your GitHub private. I guess the disadvantage to GitHub is that you can't be collaborative. Actually, wait, you can be collaborative on GitHub. That's the whole point of GitHub. Never mind. But I use GitHub more than I use Notion. Okay, what's the next box? The next box is Move. So we're going to download that. And while we're downloading it, we're going to delete the previous machine. So let's get out of here. Let's do a bit of cleanup so we can get ready for the next CTF box. Okay. Okay. So we're going to eliminado el laboratorio espere un momento, and then we can get rid of the upload stuff, and then unzip move.zip. Okay. All right. So let's run auto deploy with this new challenge called Move. So I'm not sure what this could be in reference to. Move.tar. Well, I guess we'll find out in just a second when we run our nmap scan against it. So one good thing and one bad thing about all of these Docker container challenges is that they all have the same IP address. So sometimes it's very convenient, sometimes it's just a pain in the butt, but there's an ad on Twitch right now. So let's run an ad on YouTube, and then let's bring up our birds. How about these birds? That's a lot of birds. Okay, I'm just gonna have a little drink of water. Just a sec, everybody. So these are little sparrows. You should see them everywhere. It's very, very unlikely that you live in a city where you don't see sparrows. But then the Stellar's Jay comes in. Stellar's Jays, they love peanuts. And if you live in the Pacific Northwest, you probably have Stellar's Jays in your area. They're birds like this. They're a bit like crows. They're as smart as crows, I think, and they've got this punky little hairstyle like that. They're very beautiful birds. Anyways, let's put the birds away. MC25 says it keeps the same IP every time I'd make an entry in host, so they can fall. You can assign it to FBI.gov. That sounds like. I got them where I live. Digital Warhead, are you talking about the sparrows or the Stellar Jays? Stellar's Jays. Rupert VP says, are they part of the Corvid family too? Yeah. Stellar's Jays, Blue Jays, and crows are all part of the same family. Stellar's Jays, awesome. So you must be located on the West Coast somewhere. That's my guess. They usually don't go too far east. But yeah. What are we doing? We're doing our nmap scan. We can run the same nmap scan that we did before. There's still only one port available. That's probably port 80. So it's like we're already doing our Web App Wednesday. Alright, so it's an Apache server. It's a Debian Linux system over here, from what we see. And let's do some web enumeration. So we should probably run dirb. We got index.html. Let's run nicto. This looks very familiar. This looks very, very similar to the previous system. But I guess we're gonna see what's going on with the with this system when we run our Ferex Buster. Okay, so let's run Ferex Buster and try to figure out what is on this web application. Oh, okay, Seattle area. That's not too far away from where I am. Because I live around Vancouver, BC, Canada. Don't don't use that information against me. Thank you. Thank you very much. Thank you very much for following ascertainment. Thank you. Thank you very much for following on Twitch. And here you go. How about a Hack the Planet just for you?
Hack the planet! Hack the planet!
Shut up and get in.
Shabella says, gotta bounce. Awesome stream. Hope to see you more. Hope to see you more too, Shabella, and have a great night. See you later. And why don't we give you a fun redeem as well? How about the desert frog? If anybody doesn't know what this frog is, it's the cutest frog ever. Okay, so let's see. BC is beautiful. I live between Seattle and BC. Similar climate and terrain. Yeah, it's not very. You only have to drive a couple hours to get from Vancouver down to Seattle. It's not very far at all. Rupert VP says, "What's the Ferex scan management menu TM look like?" I don't know. Maybe I should find out. If I press enter. Can I... Oh, okay. But let's see, we found index.html, icons open logo, right? And we found maintenance.html. So I guess what I should do is... we can do dynamic mods to my search. This is my first time working with Ferex Buster. So I should probably, over the next few weeks, I probably do some more experimentation with this program. It seems like a really cool program. Yeah. So let's check out index.html. We'll reload the page. Okay, so this is just a default page. I need to check it to see if there's anything interesting in the comments. I don't think there will be. It doesn't look like there is. Okay. I'm gonna try... let's try switching up the music. So there's this fun cyberpunky game called Valhalla. It's all about serving drinks to cyberpunk denizens, and it's got a really fun soundtrack. It's very retro, and I'm gonna try this out, and I hope you guys like it. And as usual, let me know if the music is too loud, because I definitely don't want it to be too loud. Okay, so we took a look at this endpoint. Let's take a look at the maintenance.html page. So it's called maintenance. Okay, so it says website under maintenance. Access is in temp_pass.txt. That's some interesting information. So can I just directly go to that directory from here? No, I cannot. Okay. So I need to figure out how to get to this file over here, the pass.txt file. And we were looking for PHP pages, TXT pages, JSON pages. Now the question is, how do we access this page that they're referencing over here? Because there's only one port open on the system. There's only port 80. Where do we go from here? We already tried scanning for TXT files. The other possibility is that we could try to do some local file inclusion, but the problem is that local file inclusion is usually associated with PHP pages, but we haven't found any PHP pages. You know what I could do is I could try using a larger word list, and the larger word list is the directory list big word list. So I'm just going to search for that, and then I'm going to try running PharexBuster again. Don't need this anymore. Locate. Let's find the big list. So directory list 2.3 big. So let's go ahead and try looking with this list. Okay, we found all the usual things. This is going to take... This could take a long while. So we can just... what can we do in the meantime? We can do some manual enumeration. Actually, you know what? Hold on. We need to take a look at the source. Let's see, MC25 says, have we seen the index.html and what it looks like? Was semi-AFK? Probably missed it if so. I think the scan management tool tells you the estimated time left for the search. Yeah, so it says here... It says here 11 minutes. 10 minutes, 9 minutes. Yeah, it says 10 minutes remaining, so we can just wait this out. In the meantime, we can do some manual enumeration. So we can just try using curl to take a look at this page. Website is under maintenance. Access is in temp.pass.txt. How do we get access to this thing? Here's the thing. There's only... Okay, let's do the same thing, but let's take a look at the index.php. Index.html, rather. Okay. Nothing... I don't think there's anything good here either. Okay, there was one other file that we found using PharexBuster, and it's this one right here in the icons directory. We could check this out. Oh, okay. Well, I don't think this helps us all that much. Okay, we can't go to this directory here. Are there any other file extensions that we could look for? We could try looking for zip files or back files. Another thing that that could be important for this challenge is the name of the challenge. because the name of the challenge is move, and I'm not sure if this is a reference to some method we should use to compromise the system or not. So maybe we should be looking for some zip files, back files, some other types of files. Let me go ahead and run another Ferex Buster that's only looking for those files. So we're going to look for zip files, back files, maybe just zip files and back files. Femyuki, hello! Nice to see you here, and welcome. We're just trying to do some Linux challenges over here. So Linux Docker challenges. User share wordless. Buster. Directory list 2.3 medium. Okay. Why did we find a PNG file? That's strange. Oh, Femyuki, you want to do !redeem space hack the planet. That's the command. So !redeem space hack the planet. And you want to make sure that the spelling is all correct. No worries, I've been having problems spelling as well today. Is recursion value 3 big enough? It should be. We haven't been running into any like super recursive directory so far, so that's not a. We didn't find Mirage. Okay, so down here.
Hack the planet! Hack the planet! Shut up again!
Thank you very much, Femyuki, for redeeming the Hack the Planet. Awesome, awesome. Okay, so this is still going. We haven't found any zip files or back files. If anybody has any suggestions for extra file types that we can look for, let us know. Zip files, back files. Wait. So just let me try something. Let me just try some. Okay. There's no temp past here. Can't see it. Alejandro says, I joined late, maybe cab? Can you tell me what you mean by cab? Thank you. I don't know. Cab files or cab file extensions? Yeah, didn't find any zip files or back files. Cab. Let's see. CAB. JavaScript. What else can be used for local file inclusion? Maybe we can take a look at different PHP extensions like PHTML, or I had a list of them. PHP-like file extensions. PHP file extensions. MC25 says, try to change the list to a file name list with the extensions. A file name list with the extensions? I don't quite follow. Could you elaborate? What are PHP extensions? Let me just ask the AI. The AI has been able to help me before with this stuff. Let's ask for provide a list of PHP compatible extensions separated by commas. Seclist file names versus a website. File names versus a website. Okay. Let me take a look at that. Okay, seclists. So we've got file extensions. Web content random files.fuzz.text. Nothing here. Medium files probably be decent start. Let me take a look. Okay, so we've got that's not what I wanted. So I want a list of PHP like file extensions, like HTML, PHP 5, etc., etc. Okay, so we've got all these over here. Is there a move file? Wait, is there a move file extension? So the name of the challenge is called move. So there might be something associated with the word move. There's no standard move file extension. Okay, just wanted to check. Let's try all of these PHP-like files over here. Just a second. So PHP uses SQL to update its admin side and to grab files. So maybe .sql? Okay, let's try adding .sql to that list. Sure. Okay, we've got all these file extensions over here. This is almost done, but I don't think we're finding anything new over here. You know what? I'm gonna try. I'm just gonna try feeding the AI like the situation and see if it can give us anything good. So maintenance. Where's my? So do we use DeepSeek or do we do? How about we try DeepSeek? Actually, no, that's not DeepSeek. Hold on. Here we are. Okay. We are doing a CTF challenge called Move. And we found a web page with this message on it. But there is no TMP directory path, and we have not found any PHP pages to try local file inclusion. Suggest options. Okay, so it often hints at a specific vulnerability or misconfiguration you need to exploit. Since you mentioned there's no TMP directory path and no PHP pages to try for local file inclusion, here are some potential avenues to explore. Check for common vulnerabilities. So even if TMP doesn't exist, the message might hint at directory traversal vulnerability. Try accessing paths like etc password or other common files to see if the server is vulnerable. Okay, we've tried this. Didn't work. Inspect the web server. Check the source code. Use tools like curl or browser developer tools to inspect HTTP headers for clues or misconfigurations. Okay, well, if there was going to be a robots.txt file, we would have found it already, I'm pretty sure. Let's check it just for the sake of completeness. Robots. Nope, does not exist. Okay, let's try. Let's try, what's this, 172, 1702. Doesn't tell us very much. Okay. Our scan is done. We haven't found anything. So let me take a closer look at the at this page right here. There might be some information I'm not getting. This is index.html. Yeah, okay. Nothing found here. Let's take a look at the Nicto output again. There might be something interested in the allow. Okay, so these HTTP methods are all very typical. So there's head, there's get, there's post, and there's options. These are very, very normal. Derb didn't tell us anything. Example.com page equals temp pass.txt. So usually Usually these kind of file inclusion attacks are associated with PHP and not regular HTML. I could give it a try. Let me give it a try. So index.html page equals tmp pass.txt. So let's do some fuzzing. Let's do a little bit of local file inclusion fuzzing over here. Actually, no. Okay, so this doesn't go. Let's do file fuzzing over here with FFUF. So we can do something like this. And we can put our fuzzing point right here. Okay, we just need to identify the size. That does not give us a successful thing. I think it's this. Pretty sure. Okay, let's try this out. Actually, there's one thing I need to do. Okay, so nothing comes of this. Did we try looking for those cab files? Let's try that out. Okay. What were some other suggestions from the AI? Explore server-side technologies, server-side scripting. So if the server's using a scripting language like Python, there's no indication. Look for hidden files or directories. Try to access files like htaccess.zip, backup.zip. Use brute forcing tools like derp, gobuster, ffuf. Symbolic links. Think outside the box. WebSockets, tools for enumeration. Re-examine the challenge name. The challenge is called move. This might hint at moving files or directories using the mv command in the shell. Play on words such as a move, referring to a chess move or a specific vulnerability. I could try taking a look at the version of the web server that's being used, because I'm starting to run out of options. Let's take a look at htaccess. Okay, so it's there, but I can't access it. tmp pass.txt. So what else could we do here? Could we revisit the prompt? Which prompt? So we did cab. Where's some other file extensions we can look for? MC25 says I had to meta this, but I don't see it as a spoiler if I say it. What metadata are you talking about? So I don't want to get super stuck. Stefan KTMS says try quick hits. Quick hits? This? Okay, we can try it. Sometimes it really is the it's very important to use the correct word list, and if you're not using the correct word list, then you are in big trouble. What is happening? Did I find a server status directory? Was that not in... Huh. Server status, etc., etc. MC25, if you have a hint, I'll take the hint, because I don't want to get super... I don't want to get super stuck. If it's something... if it's something dumb, maybe don't tell me. Actually, no. If it's super dumb, please tell me. How about that? What word list is this? This is the quick hits list. I don't even know what's on it. Quickhits.txt. MC25 says, we didn't allow enough time for it to load the Docker... What? We didn't allow it enough time for it to load the Docker. So this is the quick list list over here. Oh, a bunch of common... Yeah, okay. Didn't find anything. I haven't found anything so far. Did we find these directories? No way. Okay, okay. Kind of like how THM machines need something like 5 minutes to boot things up. Oh, are you saying that? Are you saying that we started scanning too early? Hold on. Let me try my Nmap again. So Nmap still only sees one service here. Okay, it is possible that we need to do some UDP port scanning, and if... Oh gosh. If it's... Alright. Alright, I'm going to do some UDP port scanning. I don't like doing UDP port scanning because, you know, it's very unreliable, but I guess I can give it a try. Let's see. Is it U for UDP? And we can do top ports. So the top 100 ports. Okay, how do we do... Nmap UDP scanning. SU, okay. Let's try that. We didn't allow enough time for the thing to load up. UDP port scanning. Is this a THM room? No, that's not a THM room. Actually, if you have Kali Linux with Docker installed, you can do this room yourself. This is the move machine from Docker Labs. MC says should be TCP and more ports. Not sure why Nmap is being weird. Maybe it's because Maybe it's because I'm scanning too fast. I'll scan a little slower and see if I can find the darn thing. One Gilo says, "Sup? Hello, nice to see you, One Gilo." And let's give you a fun little video redeem. How about a Nyan Cat? There you go. Okay, so we have the feeling that this Docker container should have more than one port available. So I'm going to terminate the Docker machine. I'm going to restart it. We're doing vulnerable Docker container hacking. So if you're interested in playing along, we're doing the move machine that's located on dockerlabs.es over here at this link. Okay, so we're starting up the Docker container here. We're gonna wait for a little bit for it to load up all of the services, and then we're gonna give it another Nmap scan. We don't have any Nmap scans going on right now, I don't think. Let's do a little bit of cleanup here, and I guess we'll wait for about 4 minutes. I guess that's going to take us to the top of the hour. Then we'll give the container a little scan. And we'll give it a slow scan, just to make sure that everything is okay. In the meantime, does anybody know any good jokes? Okay, that's done. And how are you all enjoying the music? Because this is probably one of my favorite gaming soundtracks. If you've got suggestions for fun gaming soundtracks, let us know. Because gaming soundtracks are less likely to get flagged by YouTube if you play them. So, although it's not guaranteed, I like to have music going on. I do enjoy like retro gaming soundtracks, and yeah, music is great. Nice to hear that you're appreciating it. Great. Okay. Let's talk a little bit more. Let's what do we talk about? Music is on point. Thank you. Let's try Hack Me. So I've been looking for different.
Hack the planet!
Hack the planet.
Hack the planet!
Shut up and get in.
Rupert VP says, "What's a frog's favorite beer?" What is a frog's favorite beer, Rupert VP? Please tell me. And actually, am I not logged in? A hoppy IPA. Nice. Okay, I need to tell everybody I'm not a robot. I was also thinking about doing some more wargaming over at overthewire.org. They've got a bunch of different games. Actually, wait, is it not this? HTTP over the wire. I did not spell that correctly. Do not spell go. Do not collect $200. So, everybody. So, in this list, which of these games have you guys tried before? There's Bandit, Leviathan, Natus, Krypton, Narnia, Behemoth, Utmo, Maze. Peanut Gamer 9 says, I got Cybersecurity Queen into doing Over the Wire. Great. So most people have done Bandit. Yeah. All right. Are you interested in seeing any other? Have you guys ever done Natus before? Natus is like the web version of Bandit. MC25 says, I did Bandit and I think Natus. Okay. And there was a reverse engineering one. Yeah, I'm pretty sure the reverse engineering one is, I think it's Maze. Only done Bandit. Aniaski has a walkthrough on Bandit, is working on Nadas right now. Yeah, I think I've seen those videos. This is let's see. Vortex. Vortex is another. There's 27 levels of this. I wonder if this is reverse engineering or not. Let's check this out real quick. Okay. This is a binary exploitation one. So your goal is to connect to port Vortex, okay, and read in 4 unsigned integers in host byte order. So this looks like a real binary exploitation or reverse engineering challenge over here. Network programming, yeah, okay. So maybe not this one until we've done a little bit more research on how to do our binary exploitation. But we've got... What are some of these other games? We've got Leviathan is a pretty... This is pretty similar, I think. This is pretty similar to Bandit. And let's just do... Maybe we could try this out. So the wargame doesn't require any knowledge about programming, just a bit of common sense and some knowledge about basics, basic Nix commands. No idea it'd be this hard to make an interesting wargame that wouldn't require programming abilities from the players. Okay, let's try the first level of Leviathan while we wait for that thing to boot up. So it's gonna be which port is it? Okay, 223. Let's try it out. So real quick, let's try SSH port 223. Okay, so it is Leviathan 0. That should be the password as well. I've never heard of this. What is this resource? Can we enter the wardrobe? Narnia. Oh, that wasn't the password? What was this resource? Oh, we're talking about overthewire.org, and they've got a bunch of different cybersecurity war games over here. A bunch of labs that are all together. There's the link for overthewire.org. Password is Leviathan 0. Hold on. Did I spell that incorrectly or something? Okay, we're in. Oh, this is the Gibson. Nice. We get to hack the Gibson. Yeah, awesome. Okay. Let's see. So what is the goal of this level? So the goal of the level is to do what? There's no information on this level intentionally. Oh, okay. So we need to figure it out ourselves. So what do we got? No. This is not that. This is not that war game. This is a different one. This is basically just Linux stuff. So there's a backup directory over here. So we just need to enter the backup directory. Bookmarks.html. And we could look for something like password. The password for Leviathan 1 is this. Okay. So we found a password in here. This is the password for the next level for Leviathan 1. Let's get out of here and log in to Leviathan 1. Paste it in. Okay, so this is Leviathan 1. Let's see what's here. Oh, there's a binary. Okay. What? This is an SUID binary. It lets us assume the identity of Leviathan 2. Okay, so If we run check, it asks for a password. We do not know the password. Wrong password. So we can run strings on this binary to make sure that there are no hardwired password. There's no hardwired password in here. I don't know. Is it love? Is the password love? Because it would be unusual to see this in the strings over here otherwise. Password is love. Wrong password. What was the other string? There's another string in there, right? Seeker. This thing. Yeah. Okay, let's try this one out. Wrong password. Okay. It had R2 and GNU debugger installed. Okay, well, we could try using Radare 2 on check. Okay, so we do all this stuff over here, and what was it? We take a look at the functions. These functions are unnamed, so that's not going to be very fun. Actually, maybe no. We've got entry. We've got an entry function. We've got a main function. Maybe we should take a look at the main function. So we would PDF at main. So it's checking for a password. So what is... Oh, okay. So we've got some... So we've got these strings over here. So there's... We could try all of these, right? Ret, God, love. Okay, let's try these out. Actually, let me copy these. Where are we? Here. Okay, let's get out of here. Gibson? That could be one of the passwords. Okay, alright. Jeez. Who knew you could get your way with that? Nice. Okay, so where's the passwords? The passwords for these levels are usually stored in a common directory, and let me check out the information over here. This is for Leviathan. Leviathan's levels. Data for the levels can be found in the home directories. You can look at etc. Leviathan pass for the various level passwords. Okay, so we can read this to get the next level password. Over here. Whoops. Cat this Leviathan 2. No. Okay, so we cat Leviathan 2. Okay, so that's the password for Leviathan 2. So we can just log in as that user, get out of here. We log in as Leviathan2 with the password that we stole. Okay. And there's another binary here. Who knew that we would be doing so much binary hacking? Okay, so that we would usage print file file name. So this, is it that easy? If it's owned by Leviathan 3, then we can just use this this binary to read the password for Leviathan 3, right? So we would do print file. What was that directory called again? Etc. Leviathan pass. Leviathan 3. You can't have that file. Okay. Why can't we have that file? We can read the Leviathan 2 file. It also says permission denied. I wonder what is getting in the way of us reading this file. Anyways, let's go back to our Docker challenge over here. Apparently there was supposed to be more than one port open on the system, but once again we only find one port. I wonder what's going wrong here. We'll wait for this thing to come back. In the meantime, we can take a look at so print file is not letting us read the password file that we want, but maybe we can read another file. Maybe we can look at, actually, what's our current directory? Home Leviathan 2. Maybe we can read Leviathan 3's SSH password. I can't have that file. Wait. Why isn't it? This is an SUID binary. It should let me read those files. I wonder why it's not letting me. Anyways, back to Nmap. Nmap's going pretty. It's going pretty slow. Maybe I shouldn't have. I need to crank up the scan time. Okay. Still only finding one port. Yeah, I'm pretty stuck on this machine. No, we can pivot. We can keep on doing Leviathan. Okay, we've got our environment. Here we are Leviathan 2. Great. See if PN helps at all. Okay, I can give it a try. Where are we? Here. Port 80. Okay, you know what? I'm gonna try re-downloading Box. So, if people tell me that there's supposed to be 2 ports open on the machine, I'm just gonna delete this machine, and then I'm gonna re-download it, and then give it a go. So rm, get rid of the auto deploy script as well, and I'm gonna re-download the machine. Okay, should be, I don't know, 10 seconds? In the meantime, I can get rid of some of these extra files that have been hanging around here. Okay, did I finish downloading the file? Yep, that is finished. Okay, unzip this thing. Alright, let's run this again. And then after it starts deploying, I'm going to wait a little bit, and then I'm going to scan it again with Nmap. So let's wait for 4 minutes, so that'll take us to the halfway mark in the hour. We've got ads running on Twitch right now, so we're going to stop, and we're going to run an ad on YouTube. There you go, YouTube. And let's play some birds. So this is super fun. Look at how unhappy this bird is. It is not happy that this other bird showed up. But you guys can watch that. Let me have a little drink. Just a second. Got another 30 seconds. These guys are super fun to have in your backyard. They're usually flying around. They're hiding they're hiding peanuts. They're bullying other birds. They're my favorite bird. Anyways, let's put the birds away and let's continue. Okay, so Leviathan over here. We're having troubles running this program here. It won't let us have these certain files. That bird was pissed. Yeah. You know what? You know what we can do? We can move this binary over to our own machine. I don't think this is super big. So we can just read the file and then base64 encode it. And we're just going to copy this binary over to our own machine so we can do a little more analysis. Here we go. And then we're going to echo base64 decode, then redirect to print file. Yeah. It's working hard because it's copying a bunch of stuff. Just a second. maybe that's not how I wanted to do it. Oh, the window is unresponsive now. Okay, so that took a long time. Let's run that. Man, why does this window not want to work? Let's just try this. Nano print file.p64. Paste that in. It works if you do it this way. Let's just kill this window. Okay, so that worked. Let me just get rid of the base64 file. Okay, so we've moved the print file binary over here. We need to identify which binaries it's using, because I'm pretty sure it's using some sort of it's using the cat command somehow. And if we actually print file, I don't think we can print anything to this directory. So maybe we can echo out HackerFrogs rule to temp directory test.txt. Okay, and then we can try using print file to read that file. So print file temp test.txt. What? Why does it say hello? Oh, okay. I actually did my... It should have been this. Permission denied. I forgot... Yeah. I forgot the greater than sign. But... Actually, who owns that file? Narnia owns that file. That's weird. But we can read that file. Okay. That's I'm gonna make this file executable, and then I'm gonna run strings on it. Actually, no. I'm gonna run strace. So I don't have it installed. Okay, I can install it. Huh, can't install it. I think... Do I have ltrace? I do have ltrace. Okay, so I can run ltrace on it. Let's try reading... What are we reading in here? I need to make something. Echo testing test.txt. Okay, so it runs bincat. It runs bincat. So that means it's not vulnerable because of like path hijacking. I can't hijack this path. So it does bincat the string where the string is equal to test.txt. It does get EUID 1000. What is EUID 1000? Let me check what the EUID for 1000 is on the system. So cat, etc. password. Grep. So the Ubuntu user. There's an Ubuntu user on here? So it sets the... and then it runs cat on whatever you're testing. I really want to run strace on this. Let's see. Sudo apt strace like this. Let's see if I can... it can't find the server here, so I can't update. Let me try... So sometimes your antivirus will get in the way of Kali Linux and being able to access Kali Linux. So I'm just going to shut down my my real-time protection, and I'm going to try accessing it one more time. Nope. Actually, you know what? They might have strace on this box. Yeah. So I just need to run strace from here. Why did I bother moving the file over? Okay. So it uses these libraries right here. So etc. ld so preload and ld so cache. I don't think I shouldn't be able to mess with these. But I mean, it's possible. Let's take a look at the file permissions. Although from if I'm metagaming, you shouldn't be able to modify these files. Let's try the ltrace one more time. Yeah, so it does run bin cat. What happens if I try to... I try to have it run on... what was it? The password over here. Via then 3. Okay, so it just tells me that I can't have that file. Now let's try strace and see if it tells me anything different. I can't have that file. But you know what? I haven't run strings on it yet. Let's run strings on this file and see if something funny happens. File printer, you can't have that file. Bin cat. Oh, you know what? I might be able to abuse this because it's running this this C-style string right here. Let me ask the AI about this. I'm doing a CTF challenge, and the binary I'm trying to hack is running this command. Can I abuse the string input to run arbitrary code? You can go ahead and think about that, DeepSeek. Let me, in the meantime, I'm going to try the other, I'm going to try Nmap one more time. Oh my god. There are a bunch of ports here now. I guess sometimes when you download stuff, it doesn't go. Now there's SSH on. There's FTP. Thank you very much to MC25 for letting me know that there is something wrong with my my Docker container there. Let's check out what's on port 3000. Okay, there's a logon page here. Grafana. I don't think I've heard of this before. There's a specific version associated with this software here. So I'm just gonna copy. I'm gonna copy it. I'm gonna search and see if there's some sort of exploit for this. And get out of here. There might be an exploit for Grafana. How do you spell Grafana? Is that a F? Okay, there's there's directory traversal and arbitrary file read. Okay, so we can, yeah, all right, we can use this exploit to get access to. Yeah, I re-downloaded it. So I guess something went wrong when I downloaded it the first time. Maybe I didn't have the complete file when I tried to unzip it, and that's why something went wrong with the zip file. So let's copy this over. So we're going to search split again, and we're going to copy over the exploit script. So it is -m and whatever number is over here. Okay. And let's rename this file. So I'm just going to call it exploit.py. Okay, so it's directory traversal and arbitrary file read. How do you run this thing? So we're going to Python exploit. We need to supply a host. So host is this. Read file. Something went wrong. What do you mean something one? Oh, wait. No. It's not. It's on port 3000. That's what's wrong. Okay, so this is the password, but I don't know the username. Let's get out of here. So we're just going to echo out whatever we just found to pass.txt. And we need to do some fuzzing. We need to figure out what username it is. We could try. I'm not too sure. It might be named Grafana, maybe. SSH Grafana 172.17.02. Okay, we need to run SSH keygen. We need to flush the SSH records for that address because we keep on using the same IP address for all of these containers. So we need to flush it so that the SSH doesn't start acting in a weird manner. Okay, so Grafana, what was their password? This. Let's just check if this is it. If this doesn't work, I'm just gonna have to do some brute forcing. Okay, that didn't work. So let's do some Hydra, and the password is going to be this thing. MC2025 says, glad it's working now. Knew something was up after you fuzzed a few times. Well, you know, Thanabata. It sounds like, welcome to the HackerFrogs, and you're now HackerFrog. Congratulations. Why don't you have one of these? This is the bully bird. This is one bird bullying another bird. Okay, so we're gonna use Hydra to brute force the SSH on this server. And we need to find a username list. So let's go ahead and find one of those. So yeah, usernames. So we got top username short list. Let's try this one first. Go back here and supply this list of names. Oh, we need to supply, okay. All right. SSH protocol error, what? Too many errors. This should be the correct IP address. What's going on here? Bubble says, I am very sad. Why are you sad, Bubbles? This is SSH. SSH is on port 22. I don't understand what's going on here. Oh, you know what? We didn't check out the FTP port. We could probably there might be the username. We might be able to get the username from the FTP service. So let's try that. Okay, so let's try FTP, right? Anonymous access. Anonymous. Okay, so I guess this is the maintenance file over here. It's in Spanish. Mantenimiento. Okay, there's a database in here. Okay, all right. KDBX. Bubble says I have to find either a kernel exploit in Horizon OS or write bare metal C code to interact with my Nintendo Switch's Wi-Fi adapter. Huh. Nintendo Switch Wi-Fi adapter. I've never done any hacking against Nintendo Switch before. It's not exactly something I know a lot about, but I wish you the best of luck trying to write your C code there. And you know what? This will help you out right here. How about you have a go and hack?
Mr. Hat, may I please be excused from class?
Well, Carl.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
I hope you can go to hack and have a great day, Bubbles. And yeah, let me know how that works. Out. Bubbles says I have CFW on my Switch and want to make it cool, like turning into a rogue access point. CFW. I don't know what CFW stands for. Let me know. Okay, let's download this database file here. And KD is that what kind of file is that? Is that keep pass? Custom firmware. Oh, okay. Let's see. Actually, you know what? That might not be SSH. This could be the login for Grafana over here. Actually, I should probably Okay. How do I interact with this file? Bubbles asks, which Linux distribution do I use? Generally, when I'm using Linux, I'm just using Kali Linux, because I use Linux as a tool for cybersecurity education. I think that's Keep Pass, right? It should be Keep Pass. How do you use Keep Pass? Nix is on top. Well, I mean, I like using Linux. It's a lot of fun. I don't know if I would use it as my everyday system. I like being able to switch between different operating systems. It's just flexibility is nice. So how do we? Can we crack this hash? Actually, wait. Can we crack this hash? Is there a keep pass to John or something? Yeah, there is. Okay. So let's keep pass to John, database dot that, and then keypass dot hash. File version is not currently supported. File version 4000 is not currently supported. It didn't write anything. Darn it. It's always something to John. Yeah? Usually is. I don't know. Maybe I can just try to access this the normal way. But what do I use to access that? Key pass to John. Yeah, this is exactly what I tried to do. So command line tools, we can install kpcli. kpcli, yeah, I don't have it installed. I think I've installed this thing before. Let's see if I can kpcli GitHub. Command line interface for KeePass database. Okay. Deprecated. The package is deprecated, no longer actively maintained. Please consider switching to KeePass XC, which is based on KeePass X and is compatible with the same file format. I think I can install this with Kali Linux. Let's see. Yeah. Well, unless I'm still having trouble. Okay, let's try installing it. It might work, it might not. Looks like it's working. Okay, so I can run KeePass CLI now. Now how do we run it? Let me start closing some of these tabs. It's starting to bother me. That's much better. Okay, what were we doing? DeepSeek, right? Right. Let's try accessing it via the command line. So these are not directly supported, but they can be imported. To import, for details, see help import. There's got to be some sort of there's got to be some sort of tool. Let's see, on here it says KeePass XC. This is commercial software. Or is it free? I'm not sure. Keep your password safe. All right. App image, okay. Well, you install all sorts of fun stuff when you do these CTF challenges. Let's so do I just run this? We'd like KeePass to check on updates on startup. Sure. Okay, so I can open a database, and I've got my database in the temp directory. Over here, it's going to ask us for the password. We have a potential password, and the potential password is this. let's see if this is the password for the KeePass database. It was. Alright, there's only one entry in here, so it's Freddy, and their password is this. Wait. That's the same password. Well, okay. Well, at least we know that the the user's name is Freddy. So let's try logging in. SSH Freddy at and this is the password. All right, we're in.
Hey everybody, it's me, Scary Hacker Voice Man. Hi, Scary Hacker Voice Man comes out every time we break into a server, and we just broke into yours. Well, Mr. Move Administrator, you thought it would be okay to give me a broken Docker container so that I couldn't access the rest of your ports, and then I had to re-download the darn thing, huh? Well, that was a big mistake. Anyways, we managed to finally get into your ports, and then we downloaded your KeePass database file. That combined with your unfortunate leaking of passwords on your... What was it even? Grafana. You had a Grafana application that was vulnerable to arbitrary file read, and we took advantage of that, and then we read your password, and then we used it for SSH, and then then we're in. Anyways, let's finish up this box so I can have dinner.
All right, so let's finish this box off. Let's what's going on here? Grafana, more like ahahaha. That's right, Rupert. That's correct. Nice, we're in. Yep, let's. Why is there a .java? Why is there .java in here? That's weird. Let's. Okay, there's a desktop directory. That's unusual. There's nothing here though. Okay, so first of all, let's figure out if we have sudo permissions. We do have sudo permissions. Okay, so this is probably our way to root. We can run as root with no password, Python 3, but we can only run it on maintenance.py. So let's check out this maintenance.py script, and we might be able to take advantage of it. So we own the script. We own the script. Okay, let's change up the music for this last little bit. And let's go back to faster than light. Okay, so because we own this script, we can write to it, and that means we can write any instructions we want to maintenance.py. So it's pretty trivial to get a root shell in this case. Oh, this is the root shell. Okay. I need to set up a new reverse shell listener. Let's do that. Okay, so we're just going to do rlwrap netcat, and then we can edit the script. So opt maintenance.py. Okay, so what we're going to do is we're going to import Wait, we don't even need to go off the box. We don't even need to go off the box to get privilege escalation here. We just need to do this. So pty.spawn bin bash. So import the pty module, pty spawn bin bash. Because we're running it with sudo, we spawn a root shell. Okay, so just save that. And then we run python, sudo python 3 opt maintenance.py. Boom, we are root.
What are you?
I'm system root.
Okay, so what happened here? So we were able to get a valid set of credentials through going zigzagging from service to service, but after we got onto the box, we found that our user could run Python as root. And if you can run Python as root, you can open up a root shell. Fortunately, well, sometimes when you can only run Python on certain files, you have to abuse the code inside those files. But in this case, we could just write to this file because it was owned by our user, which means we could write whatever code we wanted in there. And basically, we wrote up a little shell prompt, which opened up a root shell, and now we're root. So we're just going to move into the root directory, and there was an SSH. Huh. Was there an SSH key for the root user? No, there was not. Okay, so there are no flags on these Docker containers. So instead, what we're going to do is we're going to do a little bit of graffiti. So we're going to echo out to graffiti.txt, and we're going to echo out HackerFrogs was here 2025. All right, so that proves that we were here and we got access to the root directory, and we're now finished the exercise. So before we go, let me write a little after action report on this box, because it caused me a lot of problems, and I like to learn from my mistakes. Actually, how much learning was there done? That's a good question. Okay, let's write our after action report. Let's make this nice and big so that everybody can read it while I'm writing it. Okay, so there are ports 21, 22, 80, and 3000 on the system. We are able to get a database.kpdb. What is the file extension again? KDBX. KDBX file, which is a database for the KeePass app. We install a KeePass app, and then we need a password. On port 80, there is a maintenance endpoint which hints that there is a password at the temp pass.txt location. On port 3000, there is a Grafana app which is running a vulnerable software version. When we search for exploits for that version, there is a arbitrary. There's an arbitrary file read exploit which we use to read the tmp pass.txt file, which has password we can use to access the database .kdbx file, which contains a username and password. We log into the server using the stolen SSH creds, and we find our user can run Python 3 with sudo on a specific script file, which we have write access to. Okay, then we put in that code. We are root finis. Femyuki says, you used the KeyPass database only to get the user Freddy because you had the password already. So it looks like there was password reuse because we didn't have the username. We tried to do some brute forcing, but for some reason the brute forcing didn't work. I'm not sure. It might have been like a deliberate, something deliberate with the SSH server, but we were able to get the user credentials by breaking into the database. But yeah, that was an interesting experience. It took a little bit too long, but we got there eventually. All right, so everybody, we're gonna be back on Wednesday, but until then, let's find some awesome people over at InfoSec streams that we can raid into. Anya Askey is streaming right now, so she's a great cybersecurity content creator. They also do they mostly do Linux administration. I think that's what their job is. And thank you very much for following Easily Odd. Rupert VB says thanks for the stream. No problems. Catch you nerds on Wednesday. Have a good night. Have the goodest nights. Yeah. So we're probably gonna raid into Anya Askey. She's a great content creator, and she is a fellow InfoSec streamer. We're gonna be back on Wednesday. We're gonna be doing Web App Wednesday. We're gonna be doing. I think what we're gonna do is we're gonna try to do some. We're gonna storm the Nata CTF. We're gonna see how many levels we can complete over there. So if you're into web apps, and who's not into web apps, please come by on Wednesday, and we'll be hacking some web apps. But let's see, Peanut Gamer says she is doing AI clusters on Raspberry Pi. Awesome. Ken PDX says Linux administration. Okay, awesome. Yeah, Web App Wednesday. It's gonna be lit, everybody, as they say. When you arrive on Anya Askey's channel, if you could give this raid message, hip hop hack frog, hip hop hack frog, just like this, I would really appreciate it. But until then, let's do a shout out to everybody who participated in this everybody who participated in today's chat. So good friends like Cybernerd Dante, Ken BDX, Peanut Gamer 9, Rupert VB, Fem Yuki, MC25. Who else? Ronan is here. Awesome, awesome. And let's see, Bubbles, and I hope Bubbles has manages to access their Switch, because we don't want them to be sad anymore. What else? If anybody else wants to be shouted out, let me know while I'm doing this right now. One Gilo as well, Leo, and all the rest. Okay. Alright, everybody, have a fun time over at Anya Aski's channel. We will start the raid now. Oh, before we do that, let's do one last Hack the Planet.
Hack the planet! Hack the planet! Shut up and get in.
But until next time, HackerFrogs out, everybody. Say hello to Anya Aski. Please give the raid message, hip hop hack, frog frog, and we'll see you next time.